Hello there and welcome back to the SleeP Science. Tonight, the stars are already waiting for you. Above your head, a velvet black canvas stretches forever, pricked by countless points of light that look deceptively close, as if you could reach up and pinch one between your fingers. Of course, you probably won't survive this journey we're about to take. It goes well past breathable air, past warmth, past the edge of everything familiar. But that's half the fun, isn't it? So before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. And hey, drop your location and local time down in the comments. I always love seeing where you're tuning in from, scattered across this tiny planet under the same endless night. Now, dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. You start by floating upward through the dark, feeling gravity's pull fade like the volume of a song turning down. The air cools, thins, disappears, the blue fades to black. Below you the earth shrinks, a swirled marble of oceans, deserts and faint city glows. You notice how quickly huge stops meaning much out here. The tallest mountain, the deepest ocean trench both flatten to the faintest smudge. You're watching the entire human story fit comfortably under your thumb. Historians still argue whether humanity's first real understanding of cosmic smallness came with Copernicus or Galileo. Copernicus only suggested Earth might not be the centre of everything. Galileo proved it with a telescope. Either way, that tiny tube of glass in the 1600s snapped something in our collective ego. You can almost hear the gasp when people realised Earth was just another planet orbiting a star among countless others. It's like finding out the exclusive club you're in actually has a few trillion members, and everyone brought their own snacks. The Milky Way above you isn't a splash of milk at all, it's the faint collective shimmer of billions of suns. From your vantage, the band of light curves around you like a glowing river. Astronomers estimate it contains between 100 and 400 billion stars. That's a margin of error so large it could swallow entire galaxies, but it tells you something about the scale we're dealing with. We can't even count our own stars with confidence. Imagine trying to count grains of sand in the Sahara while the wind is still blowing. You drift deeper into the galactic disk, and suddenly perspective hits. The Milky Way's diameter stretches roughly 100,000 light years. That means even if you could ride a photon, the fastest traveller there is, it would take 100,000 years just to cross from one edge to the other. You picture trying to text someone across that distance. The reply would arrive around the time your species had evolved new organs. Somewhere in one of the spiral arms, specifically the Orion arm, you find a small yellowish star, our Sun. It's not particularly special, in fact, it's rather average, a middle-aged star halfway through its life. There's a gentle comfort in that ordinariness. You realise that everything you've ever known, every laugh, every heartbreak, every pizza delivery gone wrong, has unfolded in orbit around a perfectly ordinary star that itself orbits the galactic centre once every 230 million years. The last time our solar system was in this same spot in its orbit, dinosaurs were still wondering what that bright rock in the sky was doing there. You glide past the Sun and outward, past the familiar planets. Jupiter's swirling storms look like bruised marble. Saturn's rings shimmer like vinyl records catching light. Pluto, that distant snowball of nostalgia, circles in a slow, lonely ellipse. Beyond that, the Kuiper belt extends like cosmic dust glitter. And yet, even if you count all of this, the Sun, its planets, moons, comets, it's just one dot among hundreds of billions scattered through the Milky Way. A quirky little fact in 2020. Before astronomers agreed on the scale of our galaxy, there was what history calls the Great Debate. Two astronomers, Harlow Shapley and Heber Curtis, argued over whether those fuzzy patches in the night sky were spiral nebulae inside the Milky Way or entirely separate island universes. Shapley thought everything we saw was still part of our galaxy. Curtis suspected otherwise. They were both kind of right, kind of wrong. It took Edwin Hubble's later work, using a 100-inch telescope and Cepheid variable stars, to prove that the Andromeda Nebula was actually another galaxy altogether, millions of light years away. The universe suddenly got a lot bigger that night. You keep floating, the Milky Way now stretching below like a luminous whirlpool. The central bulge glows golden, packed with older stars, while the arms spiral outward, each filled with nurseries of blue-white newborn suns. You notice dark lanes cutting across the light, veils of cosmic dust that hide the brilliance beyond. If you could smell starlight, it might be like burnt ozone and ancient metal. But space has no air to carry scent, only silent photons gliding endlessly until they strike an eye or a sensor. You think about how all of this connects. Every carbon atom in your body was once forged inside a massive star that exploded long before the sun was born. The calcium in your bones, star ashes, the iron in your blood, the debris of a supernova. You aren't just in the galaxy, you are the galaxy, repackaged into walking, wandering consciousness. It's an almost uncomfortable thought, like realizing you're made of recycled starlight with opinions about Wi-Fi. Farther out, cosmic rays streak past you. Subatomic bullets born from violent supernova. They zip through your ghostly form harmlessly here, though back on Earth they'd occasionally knock into atoms in the upper atmosphere, painting faint auroras. The entire Milky Way hums with these unseen waves, radiation and magnetism, a vast, invisible symphony. To give yourself a sense of direction, you turn toward the galactic core. It lies roughly 26,000 light-years away from the sun's position, hidden behind clouds of dust. If you could see through them, you'd glimpse Sagittarius A, a supermassive black hole about 4 million times the sun's mass. The Milky Way, you realize, spins around that dark heart. There's something poetic about that, a whirl of brilliance circling silence. Historians still argue whether ancient civilizations sensed any of this scale intuitively. Some claim the Maya, with their meticulous sky charts, grasped the idea of multiple worlds or cycles. Others think those interpretations are modern projections, reading cosmic insight where there was only mythology. Still, the notion that people once looked at this same river of stars and mapped gods, serpents, and heroes across it, that's a bridge between their wonder and yours. You drift on. The galaxy's light thins near the rim. You can almost see the pattern from above now, a barred spiral, elegant and serene, but also bustling with motion. Every star, every planet, every comet is racing along at hundreds of kilometers per second. Yet from here, it all looks frozen, like glitter sealed in resin. Motion at cosmic scale happens so slowly your human brain can't register it. You're used to suns and hours, not millennia and eons. To keep yourself awake, barely, you crack a quiet joke in your head. If the Milky Way were a city, the solar system would be a single coffee shop bathroom stall, and the universe's janitor probably hasn't gotten around to cleaning it yet. It's comforting somehow that humour can exist anywhere, even in the yawning void. A soft pulse of light ripples across the scene as if the galaxy itself blinks. You're reminded that even though it feels infinite, the Milky Way is just one galaxy. There are billions more, each with their own billions of stars. Our galaxy might seem huge, but compared to the universe, it's a speck of dust in a cathedral too large to see. The Milky Way's stars form a community, but the universe beyond, that's the city, the continent, the planet beyond comprehension. You let yourself float. The silence pressing against you like soft velvet. It's easy to understand why so many people throughout history thought the heavens were divine. The scale demands reverence. Yet lying here, half dreaming, half awake, you feel no fear, just an ache of awe, the same ache that once pushed someone to polish glass into a telescope lens and aim it upward, hungry for more. The night stretches on without edges, the Milky Way spinning slowly below you like a luminous clockwork of eternity. You breathe in the thought that you're part of it, that the galaxy is not out there, but also within you. Every heartbeat echoes an ancient rhythm set long before your planet cooled, a rhythm still playing beneath the cosmic noise. And as your body relaxes, you find that the immensity no longer intimidates. It cradles you instead. You're small, yes, but you belong to something infinite. You're dust, but stardust, burning briefly, beautifully, in a universe still unfolding. You keep floating at the edge of the Milky Way's arm, watching that pale swirl of light stretch out below you like an unrolled ribbon of frost. The longer you stare, the more individual sparks resolve out of the haze, hundreds of billions of them, each a sun with its own entourage of worlds. It's a sight that makes you instinctively reach for perspective the way someone might reach for a railing on a high balcony. Counting the stars becomes an impossible dare. Even if you could name one every second, you'd be mumbling into the dark for more than 10,000 years before you were done. Your voice would run out long before the galaxy did. You glance toward the small neighborhood your species calls home. The sun sits roughly 2/3 of the way out from the center, in the quiet suburbs of the Orion Arm. Astronomers sometimes call it a minor spiral spur, which feels unnecessarily insulting to the place that invented snacks, but fine. From this perch you can see the denser Sagittarius Arm curving closer to the galactic core, bright with new stars still wrapped in violet mist. To the other side lies the Perseus Arm, fainter and older, dotted with clusters that have already burned through their youthful exuberance. You drift between them like a sleepwalker in a glitter storm. Historians still argue whether ancient observers who named constellations understood that those patterns were just line-of-sight coincidences. Some suggest the Greeks suspected depth in the heavens, that the stars weren't truly side by side. Others think they saw a flat dome, painted with divine pinholes. Either way, it's strangely moving that early skywatchers gave familiar names, Orion, Cassiopeia, Scorpio, to impossibly distant systems. It was a way to domesticate infinity, to make a friend of the darkness. Down below, the sun glows with the steady confidence of middle age, about 5 billion years old with another 5 to go. Around it orbit 8 official planets and an untidy entourage of moons, asteroids, and frozen wanderers. You think of it as a cul-de-sac on a quiet galactic street. Most stars have company. Some host dozens of worlds, others none. Astronomers estimate that in the Milky Way alone there could be more planets than stars. Hundreds of billions of tiny spheres where clouds gather, winds blow, maybe even where someone else stares upward and wonders the same things about you. A quirky tidbit drifts through your mind. In 1995, when the first exoplanet around a sun-like star was confirmed, 51 Pegasi b, scientists toasted with champagne and relief. They'd been mocked for years for chasing what some called phantom worlds. Now we catalogue them by the thousands. 1 or 2 even resemble Earth enough to stir that delicious itch of possibility. Statistically, it's hard to believe we're alone. Statistically, it's also hard to believe any of our neighbours want to deal with us, given our record on lawn care and interplanetary etiquette. You glide past a nearby cluster called the Pleiades, the Seven Sisters, bright blue and newborn in cosmic terms. The stars there are only about 100 million years old, barely teenagers by galactic standards. Their light glitters through faint veils of dust, giving the cluster that hazy dream sequence glow you remember from childhood telescopes. A few hundred light-years farther lies an older group, the Hyades, shaped like a faint V in the constellation Taurus. Each cluster is a family, born from a single collapsing cloud of gas, slowly drifting apart over time. You realise that even stars experience family reunions that end with everyone scattering. The more you observe, the more motion you notice. Every star here orbits the galactic centre, weaving its own ellipse through the spiral traffic. The sun hurtles along at about 200 kilometres per second. You picture it towing the planets like a bright kite tail, swooping through space in a perpetual, slow-motion waltz. From the surface of Earth, this immense journey is invisible, but out here, the pattern is mesmerising, a vast whirlpool of orbits within orbits, like glitter stirred in slow syrup. You pass a red supergiant, Betelgeuse, glowing with the look of a dying coal. One day it will explode in a supernova bright enough to cast shadows on Earth's night. Astronomers debate whether that will happen tomorrow or in 100,000 years. Cosmic timing isn't great at punctuality. Nearby, a cluster of smaller yellow stars twinkles with far steadier light. You catch yourself comparing them to neighbours, the flashy ones that throw loud parties and the quiet ones who mow their cosmic lawns at 7 a.m. Through this drifting observation, you start to sense scale differently. The distances between stars are so immense that light itself, the universe's fastest thing, takes years, centuries, millennia to make the trip. The nearest star system, Alpha Centauri, is over 4 light-years away. That means the light hitting your eyes tonight left there before smartphones existed. If you could somehow drive a car at highway speed through that distance, you'd be commuting for about 50 million years. Don't forget to signal when merging. Historians still argue whether humanity's first reliable distance measurement to a star, Friedrich Bessel's parallax of 61 Cygni in 1838, was the true beginning of modern astrophysics. Before that, distances were guesswork. After it, the sky had a scale. The trick involved measuring how a star's position shifted against the background as Earth orbited the Sun, like seeing a nearby tree move against a far mountain when you walk past it. The angle was so tiny that it humbled even seasoned astronomers. Infinity had, at last, a ruler. You float past a region of dark dust known as the Coalsack Nebula, a shadow blotting out the Milky Way's bright ribbon. If you could see in infrared, the darkness would dissolve into hidden stars behind it. Space loves to play peekaboo. What looks empty often just hides light your eyes can't see. You think of the old explorers charting the oceans, here be dragons, and wonder what phrase future astronomers will use for the regions they still can't probe. Somewhere in the distance flashes a nova, a white dwarf stealing gas from a companion until it bursts like a cosmic flashbulb. It's brief, dramatic, and gone. You're reminded that in the Milky Way, a few dozen such fireworks go off every year, but most are too faint or far for us to notice. The galaxy keeps its celebrations subtle, like a polite guest at a party who claps quietly. You let yourself imagine the view from one of those other suns. From there, our sun would be just another point, unremarkable, perhaps unnamed on someone else's star chart. Yet around it spins a planet where creatures build telescopes, podcasts, and existential dread in equal measure. You realize how absurdly lucky that is, a brief accident of chemistry that figured out how to look back at the chemistry that made it. A faint vibration hums through space, background radiation, the soft static left over from the early universe. You can't hear it, not really, but instruments translate it into whispers of temperature. Even out here, in the cleanest vacuum imaginable, the cosmos still murmurs to itself. It feels like the faintest lullaby, a reminder that the whole universe carries memory in its very temperature. As you drift, your thoughts slow. Each star you pass is another reminder that the Milky Way's enormity isn't cold, it's communal. It's a city of light where every point burns for billions of years, quietly keeping cosmic time. You realize that compared to the span of a galaxy, human lifetimes are fireflies, but fireflies can still light a meadow. You smile at the thought, and because the universe clearly enjoys irony, one last quirky fact arrives. If our galaxy were the size of North America, the solar system would be smaller than a coffee cup sitting somewhere in Kansas. Comforting, isn't it, that everything you know, oceans, empires, playlists, fits inside imaginary crockery? You let the idea settle. The Milky Way turns slowly beneath you, its arms stretching outward in patient spirals, like someone stirring cream into midnight coffee. Billions of neighbours, each flickering through eons, each unaware of how beautifully they contribute to the whole. You breathe, or imagine breathing, and feel the smallness as peace rather than panic. Out here, insignificance is liberation. The stars go on without you, and that's exactly why you can rest. You keep drifting outward, letting the whole disk of the Milky Way settle into view like a living mandala. The spiral pattern is hypnotic, two thick arms twining from the glowing core, a few thinner ones branching off like loose ribbons, each one stippled with starlight and shadow. It's one thing to see a telescope image. It's another to watch the structure breathe beneath you, to feel the pull of the core like a heartbeat too deep to hear. You tilt slightly and trace the span from centre to rim, about 100,000 light years, they say, though some estimates stretch that to 120. Nobody agrees precisely because measuring a thing you live inside is maddening. You can't take a selfie with the galaxy. You can only guess at your own outline. Somewhere near that bright centre, gravity rules like a patient monarch. A dense bulge of ancient stars crowds the region, gold-tinted with age, orbiting around the invisible mass of Sagittarius A. Historians still argue whether the earliest mathematicians who mapped the heavens suspected such an unseen anchor. Ancient Babylonian tablets record precise planetary cycles, but none hint that the cosmos itself might have a central engine. It took the 20th century, radio telescopes, and a streak of curiosity bordering on obsession to confirm the black hole's presence. Until then, people imagined the galaxy's glow as mere decoration, not the blueprint of rotation. You slide along the plane of the disk, through lanes of dust so thick they dim whole constellations. From Earth, those are the dark streaks that cut across the Milky Way's bright ribbon. From here, they look like bruises on light itself. The gas inside them is cold, just a few tens of degrees above absolute zero, and yet it holds the seeds of every future sun. You watch faint ripples move through the clouds, compressing, twisting. Somewhere in there, hydrogen atoms are colliding, collapsing toward ignition. The next generation of stars is gestating in silence. You get the sense of strolling through a nursery where the infants take millions of years to open their eyes. The scale tricks your perception. Even at light speed, crossing this glittering disk would take longer than modern humans have existed. The thought drifts through you like a sigh. The first stone tools, the first every word ever spoken. All of it would fit inside a single blink of this galactic lifetime. You imagine the Milky Way as an ancient city, its downtown blazing, its suburbs calmer, its outskirts half deserted. The sun lives in a quiet district far from the noisy core. You almost expect to see cosmic streetlights flickering and someone yelling at a rogue comet for speeding. A quirky tidbit floats up in the 1970s. When astronomers began mapping the galaxy with radio surveys, they discovered that our spiral has a faint bar across its centre, something invisible to the naked eye. The realization was almost accidental, like finding out your childhood home had a secret hallway. That bar seems to guide the flow of gas into the core, fueling star formation and feeding Sagittarius L. Even galaxies, it seems, enjoy a bit of interior design. You angle your view and notice globular clusters hanging around the Milky Way like lanterns. Each is a dense ball of hundreds of thousands of stars, some nearly as old as the universe itself. They orbit the galaxy's halo, loyal companions that have seen everything come and go. Astronomers still argue whether some of them were captured, stray remnants of smaller galaxies devoured long ago, or whether they were born here at the beginning. Either way, they glimmer like jewellery on the galactic crown. You drift higher above the plane, and at last see the shape most photographs approximate. A flattened disk with a bulging middle and thin, misty edges. The entire structure rotates once every 230 million years. It's a stately pirouette on a stage of darkness. You picture the sun tracing its slow oval, dragging Earth and every remembered moment of civilization along for the ride. 20 galactic years ago, our planet didn't even exist. We are newcomers still unpacking boxes in the cosmic apartment. From this altitude, the patterns become clear. Spiral arms aren't fixed things, they're waves of density, compressing matter as they move. Stars are born in this wave's crest and drift out of it as they age, like surfers leaving the break. The illusion of a solid arm is just the echo of motion. It's elegant, almost mischievous, a grand optical trick performed on the scale of eternity. Somewhere you suspect a physics graduate student is crying into a spreadsheet about it. As you turn slowly, the starlight forms a pale fog, and you feel the strange loneliness of numbers. 100 billion stars, perhaps 400 billion, maybe more. No one agrees, and maybe that's for the best. The human mind wasn't designed for this much arithmetic. You think of Galileo's first telescope, the one that could barely magnify Jupiter's moons, and realize that even he would have laughed at the idea of counting them all. We build bigger lenses, sharper sensors, yet the total always runs away from us like a mischievous comet just beyond reach. Another thought settles in. The galaxy is full of ghosts, not the supernatural kind, but the light of stars already gone, still travelling across time to reach you. What you see at this moment is an ancient snapshot, a photograph with billions of exposures overlapping. The Milky Way, glowing so serenely, is partly memory. You find that oddly comforting, proof that nothing truly vanishes here. It simply keeps shining on a delay. Below, the pyral arms shimmer with colours your eyes can't quite interpret. Red hydrogen clouds mark birthplaces of stars. Blue patches betray the youngest, hottest suns. Older regions glow yellow-white. The whole pattern looks like stained glass, lit from within. You imagine the first artists who painted the heavens on cave walls, how they'd squint up at this same ribbon and feel the same tingle of wonder, only without the math ruining it. A pulse of radiation brushes past you, a beacon from a pulsar, a neutron star spinning dozens of times per second. You catch one flash, then another, like a lighthouse signalling across impossible distances. The idea that humans have built their own beacons, radio transmissions, spacecraft messages, feels suddenly poetic. Somewhere inside this whirling disk, a species of upright apes is trying to wave hello to the cosmos. You can almost hear the universe reply with a patient, amused silence. You look again at the sheer thickness of the disk, about 1,000 light years in the dense mid-plane, thinning to wisps at the edges. Above and below, Halos of gas and dark matter envelop it all. The dark matter is invisible, yet its gravity shapes everything. It's the unseen scaffolding holding the galaxy together. Without it, the rotation speeds would fling stars into intergalactic exile. The fact that we still don't know what dark matter actually is feels like a riddle written on in starlight. Scientists propose particles, axions, hidden dimensions, take your pick. The universe shrugs and keeps spinning. Your mind drifts to scale again. If the Milky Way were shrunk so the entire disk fit inside the continental United States, our whole solar system would still be smaller than a grain of dust. And Earth? Something you could lose in a sneeze, yet somehow that dust speck invented jazz, espresso, and quantum mechanics. You smile at the absurdity of it, half tempted to apologise to the galaxy for being such noisy tenants. The spiral pattern fades slightly as you move farther out. The stars thin, giving way to the dim halo where solitary wanderers roam. Rogue stars flung free by gravitational scuffles. Orphaned worlds drifting without suns. Even exile looks serene from here. You realise that nothing in the galaxy truly stands still. Everything is in motion, everything changing, but at a pace so slow, it masquerades as eternity. Maybe that's what peace looks like on a cosmic scale. Change stretched until it feels like stillness. The Milky Way continues to turn below you, patient and bright. A home you can never traverse in one lifetime, but can always imagine. Somewhere down there, Earth spins, a faint mote orbiting a middle-aged star dreaming about what the rest of the galaxy looks like. You decide that's a lovely paradox. The galaxy is unimaginably huge, yet curiosity lets you hold its shape inside your mind for a while, like a soap globe full of stars. You linger until the light begins to blur at the edges of your vision, the colours softening into grey. The galactic disk hums like distant surf. For the first time, you understand why astronomers, poets, and insomniacs alike keep looking up. They're all trying to remember that this glow is home. You close your eyes against the glittering expanse and let the idea sink in. You're part of something vast, ancient, and beautifully indifferent. And somehow that makes the night feel kind. You drift through a darker stretch of the Milky Way, where the stars grow sparse and the silence thickens like velvet. The airless expanse feels almost humid with potential, the way an empty stage does just before the orchestra begins. Ahead, faint mists glow in pastel hues, rose, turquoise, ghostly green. You recognise them as nebulae, vast clouds of gas and dust that serve as both cradles and graveyards for stars. If the galaxy were alive, these would be its lungs, inhaling matter, exhaling light. Each one you pass looks so fragile you half expect it to flutter apart at your approach. Yet every wisp stretches for light years, containing enough raw material to build thousands of suns. The first nebula you enter shimmers like an underwater bloom. Light from young, hot stars energizes the hydrogen gas, making it fluoresce pink and red. You glide through filaments so thin they'd seem empty to any touch, but their scale is staggering. A single thread could swallow the entire solar system. Somewhere inside this gaseous labyrinth, gravity is at work, gathering atoms grain by grain until pressure and temperature ignite nuclear fusion. You are floating through a stellar nursery, a place where time moves in geological heartbeats and silence hides the roar of creation. Historians still argue whether ancient skywatchers ever saw the Orion Nebula without telescopes. Some claim its faint smudge was visible to sharp eyes in clear pre-industrial skies. Others doubt it. Either way, the first recorded observation with certainty came from Nicolas Claude Fabry de Peiresc in 1610, 4 centuries ago, when telescopes were so new they still smelled of glue. He noted a bright spot in the sword of Orion, and didn't realise he was witnessing the light of stars only a few million years old. Today, we know the Orion Nebula stretches 24 light-years across. Back then, it was just a mysterious fuzz, glowing for reasons no one could explain. You hover near a cluster of bright newborns, each only a few million years into its life, a cosmic kindergarten. They shine fiercely blue-white, burning their hydrogen fuel with reckless haste. These are O-type stars, enormous and short-lived, destined to explode as supernovae long before the sun even reaches middle age. Around them swirl smaller siblings, less massive and steadier, gathering disks of dust that may one day condense into planets. You realize you are watching the origin story of future skies, the birth of worlds that might eventually wonder about their own beginnings. A quirky tidbit surfaces: one of the first recorded cosmetic uses of stardust, real meteorite iron, dates back to ancient Egypt around 3300 BCE. Beads and dagger blades hammered from fallen iron were treasured as metal from the sky. The Egyptians didn't know that same metal once flowed in the hearts of stars, but their instinct was right. There was something divine about it. You smile at the continuity. Humans have always tried to wear a little piece of the cosmos. As you move deeper, the light dims, and you find yourself amid dark nebulae, opaque curtains of dust blotting out everything behind them. From Earth, these regions look like holes punched in the Milky Way, but from within, they feel like smoke you can't breathe. Each particle of dust is smaller than a speck of soot, yet collectively they sculpt the galaxy's shape, guiding where stars can form. Occasionally, lightning-like flashes of ultraviolet light pierce the murk as a hidden star flickers through a gap, a celestial peekaboo. You think about how fragile all of this looks and yet how enduring it is. A nebula might last tens of millions of years before its gas is used up or dispersed. Then, as new stars are born and die, their explosions recycle the elements, carbon, oxygen, iron, back into space, ready to form the next generation. The galaxy isn't static, it breathes. It's easy to forget that when staring at the night sky, where everything seems frozen in place. Here you can feel the pulse. You glide toward a region nicknamed the Eagle Nebula, home to the famous Pillars of Creation. Immense columns of dust rise like cathedral spires, each 10 times taller than the solar system. Within them, embryonic stars flicker, hidden from direct view. The Hubble Space Telescope's photograph of this place became an icon of wonder, printed on posters, coffee mugs, and phone wallpapers. Yet standing here, drifting through the quiet immensity, you realize the photo's beauty was a shadow of the real thing. The light reaching your eyes left these pillars 7,000 years ago, before writing, before pyramids, when humanity still counted time by moons. You're seeing the past glowing at you, and there's a strange tiriness in that realization. Historians still argue whether the phrase "we are stardust" first appeared in scientific or poetic form. Some trace it to the astronomer Fred Hoyle's work on stellar nucleosynthesis, others to the songwriter Joni Mitchell, whose lyrics made the idea sing in a single line. Either way, the truth holds steady. Every heavy atom, every breath, bone, and eyelash was built in places like this. The nebula's colour becomes your colour. The universe's recycling program is older than life itself. A soft vibration ripples through the cloud, shockwaves from a nearby supernova. You can't hear it, but you sense its passage, a pressure wave spreading through the gas. When massive stars die, they die violently, their outer layers blasting into space at thousands of kilometers per second. Those waves compress nearby gas, triggering new bursts of star formation. Death feeding birth endlessly, the galaxy's version of composting. You almost laugh at how neat the metaphor fits. Drifting onward, you cross the boundary between a glowing emission nebula and a cooler reflection nebula. Here, light doesn't originate from the gas itself, but bounces off dust grains, scattering into a soft blue haze. It's the same physics that makes Earth's sky blue. Shorter wavelengths scatter more easily. You remember seeing the Pleiades' blue halos in telescopic images and realize you're now flying through that very glow. Dust motes the size of smoke particles hang everywhere, glittering faintly as you pass. You slow as the clouds thin and starlight brightens again. Beyond this region, the galactic disk is a tapestry of brilliance, stitched with clusters and veiled in shadow. You realize you've just crossed from a star's cradle into its adulthood. The contrast is striking. Where nebulae pulse and shimmer, mature regions radiate steady calm. You can almost sense the balance between chaos and order that keeps the Milky Way alive. Another quirky note bubbles up from memory. Some astronomers have speculated that the smell of space, if you could breathe it, would carry hints of metal, ozone, and burnt steak. The compounds responsible, polycyclic aromatic hydrocarbons, form in the outflows of dying stars and drift everywhere. You grin at the idea that the galaxy, in some roundabout way, smells like a barbecue run by physicists. You take one last look back. The nebula glows softly in the distance, fading like the ember of a giant campfire. You think about all the suns that will ignite there, all the planets that might form, all the stories waiting in their atoms. Somewhere, eons from now, another being might gaze at its night sky and trace a faint smear of light called the Milky Way, never suspecting that within it lies the dust that once floated beside you. You feel the weight of that thought, the way every cloud here is both beginning and end, both cradle and grave. The galaxy keeps renewing itself, indifferent but generous. You let the silence stretch, the last gleam of hydrogen pink fading to black. It's a quiet kind of awe, the kind that doesn't demand answers, only the slow exhale of wonder. You drift inward now toward the galactic core, where gravity's voice grows deeper, heavier, almost musical. The light thickens, crowding around you in golden densities. It feels like stepping into a city where every window blazes at once. The Milky Way's central bulge glows ahead, a swelling sphere of ancient stars orbiting in dizzying loops. You can't tell one from another. They blur into a luminous fog, millions overlapping, weaving a shimmer that never blinks. Beneath it all, something dark awaits, hidden behind curtains of gas and dust, Sagittarius A, the black hole heart of the galaxy. You move closer, and the stars begin to whirl faster. The airless space hums, not sound exactly, but the low vibration of warped space-time. Gravity here bends light the way heat bends air. The nearer you drift, the more you feel it. A quiet inevitability, a pull that doesn't push or grab, just invites. You remember that the word gravity shares roots with grave and gravitas, seriousness, depth, consequence. It fits. There's nothing more solemn than a hole in space where light itself can't return. Historians still argue whether the modern concept of a black hole truly began with Einstein's equations in 1915 or with the wild speculation of John Michell back in 1783, who imagined dark stars so massive their light couldn't escape. Michell's idea was forgotten for more than a century, resurfacing only when general relativity gave it mathematics to stand on. You picture him, an English clergyman scribbling physics between sermons, unaware he'd predicted the most dramatic objects in the cosmos, while candlelight trembled on parchment. It's a comforting thought. Sometimes the universe tells its secrets to people long before anyone is ready to believe them. As you glide closer, Sagittarius A reveals itself not as a thing, but as an absence surrounded by chaos. The Event Horizon Telescope's images come to life here, the blurred, orange-ringed eye of gravity. You can see the accretion disk swirling around it, gas whipping at nearly light speed, heated to millions of degrees. It's an infernal ballet where matter spirals down and energy screams outward as X-rays. Yet from this distance it looks tranquil, like a candle flame seen through thick glass. Black holes have an odd elegance. They destroy everything, but they do it so beautifully. A quirky tidbit flickers through your mind. In 2010, when that first real image of a black hole was released, astronomers named one of the data processing algorithms Chirp. Someone on the team later admitted it sounded cheerful, a funny contrast to the subject matter. You imagine the universe smirking, humans giving playful nicknames to cosmic abysses. It's as if naming them could make them less terrifying. Maybe it does. You notice how stars near the core zip along at breakneck speeds, slingshotting through invisible curves of gravity. One of them, called S2, whips around the black hole every 16 years. When it passes closest, it moves at about 3% the speed of light. You can almost trace its trail, a faint streak glowing through dust. The fact that scientists tracked that orbit for decades from Earth is astonishing. They used it as proof that Sagittarius A has a mass equivalent to 4 million suns. That's 4 million solar systems, compacted into a point smaller than the distance between the Sun and Mercury. The numbers stop meaning anything, they are just too heavy to carry. As you hover, you realise the black hole isn't sucking everything in like a cosmic vacuum cleaner. Instead, it's a gravitational anchor keeping the whole galaxy in motion. Without its weight, the Milky Way's spiral would unravel, its stars drifting away into intergalactic dark. It's funny how something defined by emptiness can hold so much together. There's a metaphor in there somewhere, but you decide to let it rest. Radiation dances around you, jets of plasma erupting perpendicular to the disk. Arcing out thousands of light years before fading, they look like luminous arrows fired into eternity. Astronomers still argue whether Sagittarius A ever produced massive jets in the past. Today, it's relatively quiet, a sleeping dragon. But evidence of old shockwaves, radio lobes stretching above and below the galactic plane suggests it once roared with energy. You feel like a time traveller arriving after the fireworks, walking through smoke that still glows faintly at the edges. Closer still, gravity begins to toy with your perception. Light from stars behind the black hole bends around it, forming mirages, rings and arcs that twist as you move. It's like peering through a crystal ball full of ghosts. You think of Einstein again, who insisted black holes were mathematical curiosities, not physical objects. He would have hated being proven wrong, but perhaps he'd have admired how his equations folded space so neatly that reality had to follow. You keep your distance, curiosity is one thing, event horizon's another. Cross that line and no signal, not even light, could escape. It isn't death exactly, just erasure. A place where inside and outside lose meaning. Theories abound about what happens beyond. Crushed singularity, quantum foam, maybe an entire universe budding from the core of this one. Scientists can only guess, because observation stops at the edge. You can feel that limit in your bones, a border drawn by nature itself. Even the boldest mind has to whisper there. You remember another historical quirk. In 1974, Stephen Hawking startled the world by proposing that black holes aren't perfectly black. They slowly evaporate, leaking energy as Hawking radiation. It was a scandalous idea at first, blending quantum physics with gravity in ways no one had dared. 50 years later, it's become almost accepted, though still unproven. Somewhere in the far, far future, when galaxies have dimmed and even atoms decay, the last whisper of the Milky Way's core might vanish in a puff of quantum steam. You can't decide if that's sad or oddly poetic. The closer you float, the slower time feels. Einstein predicted it. Gravity warps not just space, but time itself. From far away, you'd appear frozen, caught in an eternal approach. Up close, seconds stretch into centuries. You wonder if that's what eternity really is, just time bent into patience. Around you, the starfield thickens until there's almost no darkness left, only a golden blur pulsing gently, like the heart of a candle. The black hole itself remains invisible, a hole cut into the glow, a punctuation mark in the sentence of creation. You stare at it and feel something between awe and calm, as though you're gazing at the universe's own pupil. Everything, stars, dust, planets, people, has been seen in a way through that gaze. Another faint memory surfaces. Early astronomers once called the Milky Way the backbone of night. Here, near its centre, you understand why. The spine holds the weight of everything, flexing under cosmic strain but never breaking. The black hole is the marrow, dense and secretive, feeding the galaxy's shape. You almost want to whisper thanks. Eventually you turn away, drifting outward again. Behind you, the glow of the bulge fades, replaced by the thin, starry haze of the disk. The silence deepens, and you feel the tug ease off your chest. It's a strange relief, like stepping out of a cathedral after a long vigil. You carry something with you now, though, a quiet awareness that the galaxy's stability depends on the very thing that consumes it. You exhale into the dark, though there's no air here to carry it, and let the rhythm of the orbiting stars lull you. Somewhere far ahead, the spiral arms stretch again, full of light and motion and noise. The heart of the Milky Way beats behind you, steady and unseen. You can still feel its echo in your pulse, a deep, slow reminder that even the smallest life is bound to the vastest silence. You drift outward from the Milky Way's golden core, letting the brightness thin until the light settles back into its familiar spiral dance. The airless quiet feels softer here, as if the galaxy itself exhales after the dense gravity of Sagittarius A. You turn slightly, following one of the sweeping arms, the Perseus arm, or maybe the Sagittarius arm. It's hard to tell from above. Both curl like ribbons of starlight around the disk, filled with clusters, nebulae, and invisible threads of dark matter. From this vantage, the Milky Way looks alive, rotating, shifting, breathing, and yet what seems like swirling motion is really the result of countless slow orbits, each one measured in millions of years. Everything moves, but nothing hurries. You decide to follow the traffic of stars as they orbit, sliding between luminous knots of gas and shadowed corridors of dust. A few rogue stars flash by, runaways hurled from their systems by gravitational quarrels. You imagine them as cosmic teenagers storming off from home after an argument. Some travel hundreds of kilometers per second, destined to spend eternity alone between galaxies. Others form traveling groups, open clusters, bound together like caravans for a few 100 million years before dispersing. One such cluster, the Hyades, still orbits not far from where the Sun makes its slow, stately lap around the centre. You wonder if our solar system once had siblings, born from the same gas cloud, now scattered among the billions. Historians still argue whether the first astronomers who tracked wandering stars across the sky, the ancient Greeks called them planets, understood they were observing entire worlds. To them, motion meant meaning, gods walking across the heavens. Yet in a strange way, their instinct wasn't wrong. Motion is meaning in the cosmos. Everything that moves leaves a story behind. The Milky Way's lanes grow busier the farther you look. Huge associations of stars travel together. Clusters orbit clusters, all bound by the invisible glue of gravity. It's like watching an ocean current made of light. Sometimes the paths intersect, galaxies, clusters, and clouds interact in slow collisions that last billions of years. You can almost see the ripples, shock fronts where gas compresses, birthing new stars in glowing waves. Chaos, yes, but organised chaos, the universe's favourite style. A quirky tidbit emerges from memory. In 2020, scientists discovered that the Sun's orbit through the Milky Way might undulate up and down like a sine wave, bobbing through the galactic plane every 26 million years or so. That means our solar system doesn't just circle the centre, it surfs it, oscillating through waves of stars and dust. If you could fast forward that motion, the solar system would look like a skipping stone gliding along a spiral river. Somewhere, a cosmic surfer would probably approve. You pass through a region dense with globular clusters, each one a glittering sphere of ancient stars bound so tightly they barely move relative to one another. These are the old-timers of the galaxy, dating back nearly to the beginning. Their stars burn with steady amber light. Low in heavy elements, cosmic elders forged before many of the universe's ingredients even existed. Some astronomers think globular clusters are leftovers from smaller galaxies swallowed by the Milky Way long ago. Others suggest they were born here, like pearls forming naturally in the galactic shell. Historians still argue which is true, though the stars themselves remain politely silent on the subject. You dive lower into the spiral arm, where dark filaments twist like smoke. The shapes remind you of rivers seen from an airplane window, broad curving, full of silt. Except here, the silt is molecular hydrogen, cold enough to freeze thought. Inside these filaments, gravity quietly works its magic, pulling gas into knots that ignite as stars. Each newborn sun pushes back against its parent cloud, sculpting cavities and sending shockwaves outward. The process is messy and magnificent, like fireworks played in slow motion. You notice faint glimmers, tiny planets forming from leftover dust, their orbits tracing new geometry around infant stars. Some will survive, others will fall into their suns or be flung into the void. But for a moment, everything feels balanced, poised on the edge of order. You realise that in the galaxy's grand rhythm, destruction and creation are inseparable beats. The traffic of the Milky Way isn't limited to stars. You pass near a swarm of comets, icy travellers from the galactic outskirts. Their tails stretch for millions of kilometres, lit faintly by distant starlight. Somewhere down there, planets are collecting interstellar dust like letters in a cosmic postal system. Meteorites still carry traces of these early days, tiny glass beads formed in stellar shockwaves. It's strange to think that a rock in someone's garden might once have orbited here, between arms of the galaxy, before gravity tugged it home. A flicker catches your eye, a nova sudden and brilliant. It brightens, fades, then vanishes back into the crowd. Every few seconds, somewhere in the galaxy, one erupts. A white dwarf stealing gas from its companion until it bursts in thermonuclear frustration. You imagine each as a brief headline in the galactic newspaper. Local star loses its temper again, neighbours mildly concerned. You continue gliding through the spiral arm and begin to feel the faint tug of dark matter streams. They're invisible, but their influence shapes everything. Stars here move slightly faster than they should, as if riding an unseen current. Dark matter makes up most of the galaxy's mass, yet we've never detected a single particle directly. Scientists propose names: WIMPs, axions, supersymmetric ghosts, but the truth remains hidden. You realise you're swimming through mystery itself, buoyed by forces no one fully understands. A soft wave of nostalgia passes through you. You remember looking up from Earth, seeing that faint band of light on a summer night, not knowing it was this whirl of gravity and flame and dust stretching 100,000 light-years across. It feels almost tender to witness it now, to know that every twinkle on that band represents hundreds of millions of suns, each with its own story. The spiral path curves again, goal, leading you toward a brighter patch, a stellar cluster glowing like a handful of diamonds. You drift closer, feeling the heat from thousands of suns packed into a space barely 10 light-years wide. This is what the galaxy looks like when it forgets moderation. Radiation sears the surrounding gas, carving cavities and scattering particles into shimmering clouds. It's spectacular and dangerous, the kind of neighbourhood no planet would want to rent an apartment in. Yet it's necessary. These intense furnaces forge the heavy elements the rest of the galaxy needs to build calmer worlds. A quirky historical footnote crosses your thoughts. The astronomer William Herschel once tried to map the Milky Way in the 18th century using star counts. He and his sister Caroline peered through their telescopes, recording thousands of points by hand. The resulting map was surprisingly accurate for its time, but limited by dust that blocked the far side of the disk. Herschel imagined a lens-shaped galaxy, with the sun near the centre. Not bad for a man working without modern detectors, though you suspect he'd have wept happily at today's radio images. The stars around you thin again, the arm curving into space like a glowing spine. You can sense the collective motion. Every object here obeys the same gravitational choreography, orbiting in predictable yet chaotic patterns. The galaxy may look serene from Earth, but up close it's pure motion, an endless swirling crowd. And yet the harmony holds. No collisions, no traffic lights, just billions of independent paths weaving into something astonishingly balanced. You linger at the edge of the spiral looking back across the disk. It's dizzying, like staring down a tunnel of light years. The central bulge gleams faintly gold, the arms curl outward in faint blue arcs, and beyond that the night deepens into black nothing. The Milky Way's motion hums softly through your awareness, a constant vibration, a reminder that everything, even silence, moves. You let the sensation settle in, a rhythm slow enough to make eternity feel like breathing. You ease your way toward the faint outer rim of the Milky Way, where the spiral arms start to fade into faint trails of lonely stars. The view shifts from crowded brilliance to something more fragile and sparse, like the edges of a fading photograph. You've left the galactic suburbs and entered the cosmic countryside, quiet, dim, and full of distance. Ahead lies a panorama of smaller companions, the faint glimmering dots of other galaxies bound loosely to our own. Together they form what astronomers call the local group, a family of about 80 or so galaxies scattered across a few million light-years of space. It sounds intimate until you remember that each member is itself a collection of billions of stars. The neighbourhood is calm, but only by cosmic standards. Here, next door, means 2.5 million light-years away. You glance back at the Milky Way. From this vantage, it's finally possible to see it whole. The spiral arms glow faintly blue and white like brush strokes of light across ink-black canvas. The bright bulge of the core shimmers at the centre, wrapped in gauzy lanes of dust. It's breathtaking, and it's humbling. You're looking at the entire structure that contains every star you've ever known, every planet ever charted, every radio signal ever broadcast. Everything human fits into a single pinwheel of starlight. You're small enough to disappear inside a thought, yet vast enough to understand it. A faint glitter catches your attention. One of the Magellanic Clouds, the Large Magellanic Cloud to be precise, hovering like a smudge of milk just beyond the Milky Way's southern fringe. It's a dwarf galaxy, irregular in shape, barely a tenth the size of ours. The ancient Polynesians used it for navigation long before telescopes existed, and European explorers later named it after Ferdinand Magellan, whose crew saw it while circling the globe. Historians still argue whether Magellan himself ever noticed it. Surviving journals suggest his chronicler Antonio Pigafetta was the real observer. Either way, the name stuck, proof that history, like light, sometimes bends around gravity before reaching us. You glide toward the Magellanic Cloud and the stars there feel different. Looser, younger, more chaotic. The galaxy orbits ours in a slow, lopsided loop like a moth caught in the light of a lantern. Streams of gas trail behind it stretching tens of thousands of light years, evidence of gravitational ties that tug at both galaxies as they dance. The gas forms the Magellanic Stream, a ribbon of hydrogen arcing behind like a comet's tail. Astronomers believe it was stripped from the dwarf galaxies as they swung too close to the Milky Way. You can almost see the motion frozen in time, two galaxies circling, teasing, reshaping each other's edges. A quirky tidbit floats up. In 2015, researchers discovered a faint bridge of stars connecting the large and small Magellanic Clouds. They nicknamed it the Magellanic Bridge, which is as straightforward as cosmic naming gets. That bridge is a reminder that galaxies don't just coexist, they interact, trade matter, and sometimes even merge. The Milky Way, you realise, has always been a social creature, quietly collecting friends and occasionally digesting them. Beyond the Magellanic Clouds, you spot other faint companions. Dwarf galaxies so dim they're almost invisible. Some, like the Sagittarius dwarf spheroidal galaxy, are already being pulled apart by our galaxy's gravity, their stars forming long streams that weave through the Milky Way's halo. It's hauntingly beautiful, the ghosts of galaxies stretched into glittering trails. The Milky Way wears its meals like jewellery. Historians still argue whether the term galaxy cannibalism is too sensational, but the description fits. Over billions of years, larger galaxies consume smaller ones, growing fatter and richer in stars. It sounds violent, yet it's just gravity doing what gravity does, redistributing matter into new shapes. You drift through one such tidal stream, and for a moment, it looks like a river of diamonds, each star carrying the memory of a lost home. You turn your gaze outward and realise that even this neighbourhood is vast beyond comprehension. The local group itself stretches about 10 million light-years across, dominated by three main members: the Milky Way, the Andromeda Galaxy, and the Triangulum Galaxy. The rest are smaller satellites, tagging along in loose orbit. Between them lies mostly empty space, thinner than any vacuum a human could make. Yet this void hums with faint radiation and invisible dark matter, binding the group together like silk threads too fine to see. The Andromeda Galaxy appears now as a faint oval smudge against the dark, a serene whirlpool of light larger than the Milky Way, and moving toward it at nearly 110 kilometers per second. It doesn't look threatening from here, just graceful, spinning lazily in the dark. You know what's coming though? In about 4 billion years, Andromeda and the Milky Way will collide and merge, forming a new galaxy astronomers have already named Milkomeda. You can't help but laugh softly at the name. It sounds like a breakfast cereal marketed to astronomers. Still, there's something oddly comforting about the idea of two galaxies finding each other after so long. You imagine the collision. Stars won't actually crash, they're too far apart. But their gravitational fields will twist everything. Spiral arms will stretch, cores will ignite with new star formation, and the night sky from any surviving planet will become a storm of light. The process will take billions of years, a cosmic slow dance that ends not in destruction, but in rebirth. Somewhere, future beings, if any exist, will look up and see a sky brighter than any sunset, and call it beautiful without knowing they're witnessing the blending of two galaxies. You pass through the outskirts of the local group now, where the Milky Way's gravitational influence fades. Distant galaxies shimmer faintly, members of the next cluster over, the Virgo supercluster, beckoning like a metropolis beyond the horizon. But for now, you linger near home. You can sense the balance that keeps this galactic family together, each member tugging, pulling, whispering through gravity. It's a quiet equilibrium, the kind that could last for eons unless something larger disturbs it. A quirky fact drifts in. In the 1930s, Edwin Hubble, yes, that Hubble, wasn't sure whether galaxies were scattered randomly or grouped. Using photographic plates and a healthy dose of guesswork, he realised they formed clusters, superclusters, and filaments of filaments, a cosmic web stretching across space. The local group, he noted, was just a thread in that web. Imagine discovering that your entire galaxy is merely a bead in a necklace that spans the universe. You take one last look at the Milky Way, now reduced to a glowing spiral floating in the dark. From here, it's smaller than you'd expect, almost delicate. You can trace its arms, see its satellites, sense its motion, and somewhere inside that swirl, On an unremarkable arm of a middling galaxy, a blue planet spins, sending faint radio murmurs into the night. The thought feels both comic and profound. A species made of stardust whispering to the stars, asking if anyone's home. The local group stretches before you, peaceful and endless. Every galaxy spins, every orbit continues, every beam of light slides through space on its impossible journey. You float among them, feeling the slow pulse of gravity, tying it all together. The Milky Way fades behind you, a glowing echo of home in a universe that seems somehow infinite and intimate at once. You angle yourself toward the faint oval shimmer of Andromeda, the nearest large galaxy and, if you could feel fear out here, perhaps the most intimidating neighbour imaginable. From this distance, about 2.5 million light-years, its light looks delicate, almost tender. Yet every photon hitting you now began its journey back when early humans were just figuring out how to spark fire from stone. You drift closer, and the mist sharpens into structure, a magnificent spiral of billions of suns, its arms stretched wide like ribbons caught in a slow cosmic wind. The Milky Way may be home, but Andromeda feels regal, broader, brighter, and unapologetically confident. It's easy to forget how massive it is. Andromeda spans roughly 220,000 light-years, more than twice the diameter of the Milky Way. Its total mass, counting invisible dark matter, could be nearly 1 trillion times that of the Sun. You realize that if the Milky Way is a gleaming city in space, Andromeda is a sprawling empire glowing in the night. Historians still argue whether Persian or Roman analogies fit best for the way ancient civilizations expanded until they collided with their neighbours. Astronomers make the same comparisons now, speaking of galactic conquests and mergers, with a faint glimmer of poetry in their equations. You slide closer, passing through faint outer streams of stars that trail far from the main disk. These are tidal remnants, proof that Andromeda has already devoured smaller galaxies over its lifetime. In the past few billion years, it's cannibalized dozens of dwarfs, their stars now absorbed into its halo like forgotten citizens of conquered lands. Some of those ancient travelers might even have come from the same group as the Milky Way's earliest companions. It's strange to think that both galaxies have spent eons reshaping each other's surroundings long before their final dance begins. A quirky tidbit bubbles up. In 1923, Edwin Hubble used a telescope at Mount Wilson Observatory to study what was then called the Andromeda Nebula. Through careful observation of variable stars, Cepheids that rhythmically brighten and dim, he proved it wasn't a nearby cloud at all, but a separate galaxy far outside our own. That discovery rewrote the universe overnight. Before that, many scientists believed the Milky Way was the entire cosmos. Afterward, humanity suddenly found itself in an ocean of galaxies, each a universe in miniature. You imagine the thrill of that moment, the realization that the night sky wasn't just a ceiling but an infinite cityscape of lights. You continue drifting inward. The spiral arms of Andromeda unfurl around you, glowing blue-white where new stars form, tinged with pink from clouds of ionized hydrogen. Dark lanes of dust curve between them, sculpting shadows that stretch for thousands of light-years. The closer you get, the more depth you perceive, like diving into a whirlpool made of stars. Clusters, nebulae, and supernova remnants sparkle in every direction. The galaxy hums with activity, yet the silence remains complete. You wonder if sound could ever exist here. What symphony billions of suns might play if only space could carry it. Historians still argue whether Hubble or his colleague Henrietta Leavitt deserves full credit for the discovery that made this journey possible. Leavitt was the one who first established the relationship between a Cepheids' brightness and its period, effectively inventing the cosmic yardstick that allowed Hubble to measure distance. Her contribution went largely uncredited during her lifetime, a familiar pattern in science. You send a silent nod of respect across the centuries to the woman who first taught humanity how to measure infinity with rhythm and light. You pass through a dense region called NGC 206, a star-forming complex inside Andromeda's disk. It glows with the electric blue of young massive stars, each one 1,000,000 times more luminous than the Sun. Around them drift smaller reddish dwarfs, patient and steady. Some of these systems may already host planets, others will someday. The galaxy is busy making its next generation. It feels oddly domestic, cosmic maternity on a grand scale. You drift past the region slowly, as though not to disturb anything. Beyond the arms, a faint sphere of older stars stretches outward, the halo. Here lie globular clusters, each a tight ball of tens of thousands of ancient suns. One of them, Male 2, also known as G1, is so massive it may be the leftover core of a small galaxy that Andromeda swallowed long ago. You imagine each cluster as a pearl on an invisible necklace, ornaments on a queen who long ago stopped counting her jewels. A quirky modern fact slips in. When astronomers simulated the future Milky Way Andromeda collision, they discovered that our solar system probably won't be destroyed but flung into a new orbit, possibly near the outskirts of the merged galaxy. The sun, by then swollen into a red giant, will be old, tired and dim, but Earth will already have been scorched beyond habitability, yet the night sky, if anyone remains to look, will be spectacular. Enormous arcs of light crossing from horizon to horizon, galaxies intermingled like luminous brushstrokes. It's both apocalyptic and beautiful, the kind of ending nature specializes in. As you explore Andromeda's core, the starlight thickens to near solidity. The nucleus blazes with hundreds of millions of stars packed into a space barely a few light years wide. Somewhere within lies a pair of black holes spiraling toward each other, the result of an ancient galactic merger. They haven't met yet, but their gravitational pull already shapes the surrounding orbits. You can almost feel the tension, like two notes held just before harmony. When they finally collide, billions of years from now, the resulting gravitational waves will ripple across the cosmos, perhaps brushing through whatever the Milky Way has become by then. Historians still debate whether Andromeda has already passed through an early stage of merging with us. Some evidence suggests streams of shared stars between the two galaxies, as if the first strands of the future Milky Way have already begun to weave. Others argue those are just coincidences of perspective. Either way, the cosmic waltz is underway. You watch it, knowing you're seeing both history and prophecy in the same frame. You retreat slowly, taking in the full panorama. The Milky Way glows faintly in the distance, a smaller spiral compared to Andromeda's sprawling form. Between them stretches the intergalactic void, dark, immense, and secant. Yet even that void isn't empty. It's laced with invisible filaments of gas and dark matter connecting the two galaxies like the faint tension of a drawn bowstring. The gravitational pull grows, and though you can't feel it, you know it's drawing them together inch by inch. One day, long after Earth's mountains have eroded and its oceans have boiled away, those two spirals will embrace. You linger at the edge of Andromeda, reluctant to leave. Its scale is mesmerizing, but it's the sense of continuity that grips you. The feeling that this vast, swirling structure is part of a single unfolding story. The same story that began when the universe was only a fraction of a second old. You realize that collisions, chaos, and creation aren't interruptions in that story. They are the story. The galaxies may merge, the stars may die, but the music of it all keeps playing, a rhythm too deep for time to silence. As you turn back toward the void, Andromeda's light follows you, a distant lantern, in infinite night. The space between galaxies opens wide, patient and endless. You exhale, though no breath escapes, and feel a quiet calm settle through you. The dance has already begun. You're just lucky enough to be awake to see the first step. You float in the silence between galaxies, where even the concept of distance begins to lose meaning. Behind you, the Milky Way and Andromeda gleam like twin spirals caught in an eternal slow dance, their faint arms stretching toward each other, across a darkness so deep it almost hums. Ahead, the night thickens, not with emptiness, but with light so distant it merges into a faint, gauzy mist. You've entered the cosmic web, the grand architecture of the universe, where galaxies assemble not randomly but along invisible filaments of gravity. From here, you can see the structure of everything, a lattice of light spanning billions of light years, clusters glowing at intersections like pearls on an unseen net. For a moment, you feel the strange paradox of the universe, infinite and finite all at once. The scale defies imagination. There are hundreds of billions of galaxies out here, each holding billions of stars. You realize that counting them is like trying to measure the wind with a teaspoon. Astronomers estimate at least 2 trillion galaxies exist in the observable universe, but that number keeps shifting upward as telescopes grow sharper. Somewhere out there, entire galactic superclusters shimmer beyond any map we can make. The cosmos isn't just large, it's still expanding, stretching faster every moment, as if the very fabric of existence refuses to stand still long enough to be understood. Historians still argue whether humanity's first true glimpse of this immensity came from Edwin Hubble's discovery in the 1920s, or from the later Hubble Deep Field images in the 1990s, when a small patch of empty sky revealed thousands of galaxies hiding in plain sight. The difference is mostly emotional. In the 1920s, the universe became big. In the 1990s, it became overwhelming. The deep field photos turned the void into a treasure chest. Every pixel held hundreds of millions of suns. You imagine the astronomers who processed those images, staring at their screens in awe as they realized the universe was both stranger and busier than anyone had dared to dream. You drift toward a dense cluster known as Virgo, the heart of our local supercluster. It's a city of galaxies, thousands of them glowing like streetlights in the cosmic night. Some are spiral, others elliptical, some irregular and scarred by ancient collisions. The brightest among them, M87, sits at the cluster's core, its enormous black hole blasting out a jet of plasma nearly 5,000 light-years long. You can see it faintly now, a glowing lance piercing the dark, marking the center like a cosmic exclamation point. In 2010, astronomers captured the first ever image of a black hole here, another blurred orange ring, not unlike Sagittarius A's, but far grander. It was the first time humanity saw a shadow cast by gravity itself. A quirky tidbit surfaces. When that image of M87's black hole was released, people online compared it to a donut. Astronomers laughed, then leaned into the joke, even naming the telescope network's central calibration target the donut. It's a reminder that no matter how vast or serious the universe feels, humans will always find a way to make it slightly absurd. You picture cosmic beings looking back at us, wondering why we're naming gravitational abysses after pastries. You move deeper into the Virgo cluster, weaving between galaxies like a slow tourist on an infinite boulevard. Here, collisions are common. Galaxies brush past one another, trading streams of gas and stars. Some are stripped bare, their star formation quenched by the heat of the cluster's plasma halo. Others burst to life again, reignited by gravitational tides. The scale of interaction is breathtaking, whole galaxies behaving like raindrops merging on its window pane. Yet amid the grandeur, everything still moves according to the physics as simple as the fall of an apple. Historians still argue whether Isaac Newton ever looked at the Milky Way and imagined his laws reaching this far. He couldn't have known that the same gravity pulling an apple down would also sculpt clusters and superclusters. The irony is sweet. The universe runs on the same principles you can demonstrate with a pebble in a pond. Every galaxy's orbit, every cluster's shape, every filament's arc, they're just gravity painting on a cosmic scale. As you look around, you realize the galaxies don't fill space evenly. They gather in sheets and filaments, leaving immense voids between them, vast spherical regions nearly empty of stars. One of the largest, the Boötes Void, spans hundreds of millions of light-years. From its center, the nearest galaxy would be farther away than any human radio signal has yet traveled. You shiver, though not from cold. The voids feel ancient, serene and savagely sad, like the universe paused there to take a breath and never exhaled. You drift toward one of the filaments connecting the clusters. It glows faintly with intergalactic gas, illuminated by scattered X-rays and the ultraviolet flicker of distant quasars. Those quasars, supermassive black holes feeding greedily on infalling matter, shine brighter than entire galaxies. Their light has travelled for billions of years to reach you. Some are so distant that you're seeing them as they were before Earth even formed. You marvel that photons, weightless travellers, can survive journeys so long they outlive continents, languages, and species. A quirky detail: in 1963, when astronomer Martin Schmidt first identified a quasar, its redshift was so extreme that many thought his calculations must be wrong. The idea that something could be billions of light years away and still shine so brightly seemed impossible. Yet it was real. Proof that the universe extends unimaginably farther than anyone had guessed. That discovery didn't just expand our maps, it expanded our humility. The deeper you look, the more galaxies you see. tiny flickering points beyond the reach of any telescope. You realize you're no longer looking at galaxies, but through them, peering into the scaffolding of the cosmos itself. The web stretches on endlessly, its filaments connecting clusters like neurons in a universal brain. Perhaps that's all the universe really is. Thought made vast, awareness stretched thin across time and space. The idea seems both poetic and slightly dangerous, the kind of thought that could keep a philosopher awake for eternity. Historians still argue whether the term cosmic web captures the right image. Some prefer cosmic foam, pointing out that galaxies line the surfaces of enormous bubbles. Either way, the structure feels organic, alive. You watch filaments pulsing faintly as dark matter and gas flow along them, feeding the clusters like veins feeding a heart. Somewhere new galaxies are still forming, others merging, others fading. The universe is not static, it's a living system in slow motion. You glance back once more, the Milky Way has gone from sight, lost among billions of its kind. It's like trying to spot a single grain of sand from an airplane, and yet knowing where you came from brings a strange comfort. You realize that belonging doesn't require prominence, it requires perspective. To be part of this vast lattice of light is to participate in something far grander than survival. It's to exist in the story of everything. You float there for a long moment, watching the cosmic web shimmer. The galaxies glimmer like fireflies in a field too large to cross, and the dark between them feels like a promise rather than an absence. You can sense that this is only the beginning of the universe's story, not its end. Expansion continues, acceleration grows, and the fabric of space keeps stretching toward futures you can't yet imagine. For now, though, you let yourself rest in the in-between, weightless and small, surrounded by all the light that ever was and all the darkness that will be. The cosmic web breathes around you, silent and eternal, and you breathe with it. One speck of awareness adrift in an infinite sea. You linger in that shimmering cosmic web, suspended between galaxies that pulse faintly like the embers of a sleeping fire. The light is ancient, older than mountains, older than the elements in your bones. And then, faintly at first, you begin to sense a soft background hum, a whisper that seems to come from every direction at once. It isn't the hum of galaxies or the rush of gas through clusters. It's older than all of that. This is the universe speaking in its oldest language, the cosmic microwave background, the faint afterglow of the Big Bang. The signal wraps around you like static, faint and even, its temperature just 2.7 degrees above absolute zero. It's so uniform that early scientists nearly missed it, mistaking it for the noise from their instruments. Yet this radiation is the oldest light we can see, a fossil snapshot from 13.8 billion years ago, when the universe was only about 380,000 years old. You imagine that era, a glowing fog of hydrogen and helium filling every direction, hot but quickly cooling. There were no stars yet, no galaxies, only the soft orange-red glow of matter, settling into the calm that would one day allow everything else to form. Historians still argue whether Arno Penzias and Robert Wilson truly understood what they'd found when they stumbled across that signal in 1964. They were radio engineers, not cosmologists, just trying to get rid of a persistent hiss in their new antenna. They even cleaned pigeon droppings from the dish, convinced that was the cause. Meanwhile, a team at Princeton, led by Robert Dickey, was preparing to look for exactly such a signal. When Penzias and Wilson called to compare notes, history clicked into place. Their accidental discovery earned them the Nobel Prize and gave humanity its first tangible proof of the Big Bang. Somewhere in all this cosmic grandeur, a pigeon unintentionally assisted in confirming the origin of everything. You tune yourself to that faint radiation, letting it wash through you. It's not light anymore in the way you think of light. It's been stretched by expansion until its wavelengths have grown long and lazy, sliding into the microwave band. Yet it still carries information, the fingerprints of the universe's childhood. Slight variations in its temperature, only millionths of a degree, reveal the seeds of every galaxy, every star, every person. You're literally surrounded by the blueprint of existence, the first quiet echoes of what would become home. A quirky fact arises when the cosmic background was first mapped in detail by the COBE satellite in 1992. The data was so exquisite that the project leader, George Smoot, famously declared, "If you're religious, it's like seeing the face of God." The image looked like a softly mottled oval, painted in shades of gold and red, small temperature fluctuations that became the large-scale structures you just travelled through. Those tiny ripples were gravity's first whispers, the wrinkles in the infant universe that would later stretch into galaxies. As you drift, the static hum deepens, and you realise you're hearing, not with ears but with imagination, the sound of creation itself. Scientists have even converted those ancient temperature variations into audio frequencies, the universe's first song. It's not melodic, more of a low, rising whoosh, like wind through distant trees. You imagine it looping forever, expanding outward, a lullaby older than time. Historians still debate whether calling this the sound of the Big Bang is poetic license or scientific accuracy. Technically, there was no sound in the vacuum of space, yet the early universe wasn't vacuum, it was dense plasma, and pressure waves did ripple through it, like sound through water. Those primordial waves, frozen into the cosmic background, are why galaxies form in clusters and filaments today. Every structure that you've seen is, in some sense, a fossilized echo of that first universal note. You drift backward in time, at least conceptually, following the redshift trail of the background radiation to its origin. You pass through epochs with names that sound both grand and obscure. The recombination era, when atoms first formed, the Dark Ages, before stars lit up the void, the Rionization epoch, when the first galaxies ignited. Each sketch feels like a page turning in an invisible book, written not in words but in physics. You imagine what the universe looked like before light could travel freely. It was opaque, a fog of charged particles scattering photons in every direction. Then, as the temperature dropped below 3000 Kelvin, electrons combined with protons to form neutral atoms, and suddenly light could move unhindered. That first flood of radiation became the cosmic microwave background still washing over everything today. Every second, billions of those photons pass through you, through Earth, through every atom in the universe, unnoticed but eternal. A quirky anecdote. In 2003, the WMAP satellite refined the map of this radiation so precisely that scientists could date the universe to an age of 13.7 billion years, with an error margin smaller than 1%. For something that began in chaos, the precision feels almost ridiculous. Imagine measuring the age of eternity and rounding to the nearest 100 million. You notice faint patches in the background where the glow dips slightly cooler or warmer. Those are the fingerprints of dark matter, the invisible scaffolding you passed through earlier. Where dark matter clumped, gravity pulled ordinary matter along, creating slightly denser regions that would one day collapse into galaxies. Where it was sparse, space expanded unimpeded, leaving the vast voids you saw between filaments. The pattern is mesmerizing, like frost spreading across glass, delicate and inevitable. Historians still argue about the interpretation of one feature in that ancient light, the so-called cold spot, a vast area slightly cooler than its surroundings. Some think it's just a statistical fluke, the universe's version of a birthmark. Others believe it may hint at something beyond the observable universe, perhaps a region where our cosmos brushed against another during inflation. The idea of universes colliding like soap bubbles is dizzying, yet strangely plausible. You can't help but smile. Even the universe might have scars from childhood. The hum of the background fades into a near silence so deep it almost aches. You realize you've drifted as far back as light allows. Beyond this, no photons can reach you. It's not a wall exactly, but a horizon, the limit of visibility. Beyond it lies the universe before light, before transparency, before memory. You're staring into a time when physics itself was still deciding what rules to follow. You let the realization sink in. Every observation, every telescope image, every human theory is built from this faint afterglow. We read the universe like archaeologists brushing dust off the oldest relic we can still touch. And what's most beautiful is that the relic is everywhere. Even now, that ancient light glides through your body, through the air you once breathed, through oceans and mountains and clouds. You are literally bathed in the memory of creation. A small but amused thought drifts through. If you could see in microwaves instead of visible light, the night sky wouldn't be black at all. It would glow faintly, perfectly uniform, like a soft cosmic wallpaper. You'd never be in darkness again. You'd live forever inside the afterglow. Maybe that's not so different from the truth. You float there, listening to the universe's quiet background music, feeling impossibly small yet deeply connected. The radiation fades into stillness, and with it comes a calm unlike anything you've known. Somewhere behind the noise of galaxies, behind the static of time, there's only this. The hum of everything that ever was, still whispering, still expanding, still warm enough to remind you that the universe, for all its coldness, never entirely forgot how to glow. You drift beyond that ancient whisper of microwaves, the last visible relic of the Big Bang fading behind you, until it becomes a suggestion more than a sound. The universe around you seems almost empty now, but it isn't still. Not really. Space itself is stretching, expanding, unfurling in all directions, like a slow-motion balloon that no one remembers inflating. Every distant galaxy drifts away. Every ray of light stretches longer, redder, cooler. You can sense the pulse of expansion as a kind of gentle pressure, the universe's slow cosmic breath. Astronomers once thought this breath would someday reverse, that gravity, the great gatherer, would tug everything back together in a fiery big crunch. But the more they looked, the more puzzling the data became. Instead of slowing, the universe's expansion was speeding up. Galaxies were not just moving apart, they were fleeing faster and faster, as if pushed by some invisible hand. Historians still argue about the exact moment this revelation sank in, but 1998 was the year two teams, both studying distant supernovae, stumbled onto the same shocking truth. Something unknown was accelerating the universe. They called it dark energy, a term that meant essentially we have no idea. You imagine those scientists checking their data again and again, certain they had made a mistake. It must have felt like catching the universe cheating on gravity. Yet there it was, supernovae dimmer than they should have been, their light stretched farther by space, expanding faster than anyone expected. The discovery earned the teams a Nobel Prize, and also a permanent headache for physics. Dark energy now accounts for nearly 70% of the universe's total energy. You try to picture that. Almost everything that exists is something we cannot see, cannot touch, and cannot define. The cosmos apparently has a flair for mystery. You move farther into intergalactic space where the galaxies drift like distant ships in a dark sea. The expansion becomes tangible, not as speed but as separation. Every point of light you look at is sliding away, its glow shifting toward red, wavelengths stretched like taffy. It's as if the universe is playing a slow, infinite jazz riff, every note expanding, deepening, cooling. The farther away a galaxy is, the faster it recedes. You recall the name Hubble's law, though the idea wasn't entirely his. Georges Lemaitre, a Belgian priest and physicist, actually derived it first. Historians still debate whether Lemaitre's modesty or his nationality kept his name off the law. Either way, his insight stands. Space itself carries galaxies apart, not like marbles flung through air, but like raisins in a rising loaf of bread. A quirky fact drifts through your thoughts. The space between the Milky Way and Andromeda is still small enough that their gravity overpowers this cosmic expansion. There are exceptions to the rule, tiny eddies in a cosmic current too vast to feel locally. But farther out, no such bond holds. Beyond our local group, every galaxy is sailing away for good, carried by dark energy's relentless push. You realize that in the far future, an observer inside the Milky Way will see only darkness. Other galaxies will have receded beyond visibility, leaving a lonely island adrift in eternal night. It's tragic and elegant at once, like watching candles fade in a cathedral whose walls keep stretching outward. You glide through that deepening dark and you can almost sense the fabric of space expanding around you. There's no wind, no sound, no resistance, just the quiet motion of geometry itself changing scale. It's easy to confuse expansion with movement, but the galaxies aren't really traveling through space. Space itself is growing between them. You're not watching the universe move, you're watching the metric of existence rewrite itself in real time. The realization is dizzying and you laugh softly, because what else can you do when space starts editing its own map? Historians still argue about whether Einstein himself ever regretted introducing his cosmological constant, that famous fudge factor he once called his greatest blunder. Ironically, the constant he invented to keep the universe static may actually describe dark energy. Somewhere, you hope, Einstein is grinning in cosmic afterlife smugness. Physics, it seems, occasionally circles back to apologize to its old heroes. You spot a distant quasar, its light stretched to a dull crimson by expansion. Billions of years ago, it would have outshone its entire host galaxy. Now its brilliance arrives softened, tired from travel. It's a reminder that expansion not only separates galaxies, it ages light. Photons lose energy as space stretches, their wavelengths lengthening like sighs that never end. Every redshifted glimmer is a record of how long the universe has been running, a natural clock marking its own breath. A quirky modern note comes to mind. Some physicists propose that dark energy might not be constant at all. They call the idea quintessence, only a throwback to Aristotle's fifth element, the pure substance beyond earth, air, fire and water. If they are right, dark energy could change over time, perhaps even reverse. It's comforting in a way to know that even the universe's fate might still be negotiable. You drift farther and watch how the galaxies arrange themselves on the grandest scale. Clusters and filaments recede, their motion subtly accelerating as though they're sliding down invisible slopes. Between them, the voids grow wider, colder, more absolute. In some places, entire superclusters vanish from sight, their light stretched beyond the limits of detection. You realize that the farther into the future you look, the lonelier the cosmos becomes. If you waited long enough, the observable universe would shrink, not because the galaxies vanish, but because their light can no longer outrun the expansion. One day, the night sky will go completely dark, and future astronomers, if any exist, will see only their own galaxy, never guessing that others were ever there. Historians still debate whether that distant solitude will mark the end of science. Some argue that without cosmic clues, future beings will reinvent a smaller geocentric model of reality, never knowing how large it once was. Others believe the memory of the wider cosmos will persist, encoded in ancient data, whispered through generations like myth. You prefer the second theory. The universe forgets nothing, it only hides its memories in the redshift. You feel the rhythm of expansion as you drift. It isn't violent, just persistent, gentle, inexorable, or unstoppable. Even as it pulls galaxies apart, it also holds the promise of new beginnings. Somewhere in regions too distant to ever see, new stars are forming, new planets turning, new beings perhaps looking back through their own skies, wondering what lies beyond the last visible light. A final quirky image comes to you. In 2011, NASA's WMAP data showed that the universe's overall geometry is astonishingly flat. Not curved like a sphere, not saddle-shaped, just perfectly balanced. Flat within a margin of error smaller than your fingernail. It means that space, on average, expands uniformly in all directions. The universe, despite all its chaos, obeys opposite symmetry with unnerving precision. It's as if creation signed its name with a ruler. You linger a moment longer in the stillness, imagining the universe's expansion as breath, an eternal inhale that may never exhale. Dark energy hums at the edge of perception, patient, tireless, invisible. You feel both tiny and infinite, part of the equation, and yet outside it. An observer suspended in the slow unfolding of forever. Somewhere behind you, galaxies still collide and stars are born. Somewhere ahead, everything drifts quietly apart. You close your eyes, not to escape the vastness, but to let it settle around you like a blanket. For all its emptiness, the universe feels strangely full. You let that silence of expansion fade behind you and drift towards something stranger still. The invisible force that makes the universe accelerate faster with every passing eon. It's everywhere and nowhere, a kind of pressure hiding in the emptiness, so evenly spread that it seems almost bored with its own perfection. Astronomers call it dark energy, though that name explains nothing. It's not dark the way shadows are dark, it's dark the way ignorance is, something we know exists only because of what it does to everything else. The farther you go, the more you feel it, not as a tug, but as a stretching, a soft insistence from every direction. The galaxies you passed earlier are slipping farther apart. Light from them grows thinner, redder, cooler, until it feels like time itself is losing energy. If gravity is the universe's desire to gather, dark energy is its urge to let go. You realize with a flicker of unease that the universe might prefer solitude. Historians still argue whether Einstein's original cosmological constant was a premonition of this force, or a mathematical coincidence. He added it to his equations reluctantly, just to keep the universe static, then removed it when expansion was discovered. Decades later, cosmologists dusted it off and found it matched the new data uncannily well. If it wasn't prophecy, it was the neatest accident in physics. You imagine Einstein frowning under that moustache, chalk in hand, muttering "told you so" to the void. You reach a region of near total darkness, intergalactic space so empty that even dust has given up. Here, the vacuum is not absence, but energy. Quantum fluctuations pop in and out of existence, tiny particles that appear, pair, and vanish before they can be measured. It's restless nothingness. The universe is idle fidgeting. Some physicists suspect dark energy may arise from these fluctuations, a kind of vacuum pressure woven into space-time itself. The math, however, produces absurd results. The predicted energy is off by a factor of 120, the biggest numerical mismatch in science. The universe, apparently, doesn't follow our calculator etiquette. A quirky tidbit drifts through your thoughts. In 2013, a group of researchers half-jokingly proposed that dark energy might just be the weight of nothing, an artifact of quantum fields refusing to shut up. They compared it to the hum left in a room after an amplifier is turned off. If that's true, then the entire cosmos is vibrating with residual noise from creation, and what we call expansion is just the echo of that original feedback. You can't decide whether that's reassuring or terrifying. You glance around and imagine this nothing as fabric, an ocean too smooth to ripple, too vast to swim. Every cubic meter of it carries a tiny push, almost negligible, but when multiplied across the observable universe, the total force is overwhelming. It's the perfect contradiction, infinitesimal everywhere, omnipotent together. You realize that dark energy isn't fighting gravity so much as it's redefining balance. The universe, left alone, will keep stretching forever, galaxies drifting beyond sight until each becomes its own isolated island, marooned by the very emptiness it floats in. Historians still argue about what that means for time itself. If expansion continues accelerating, distant galaxies will slip beyond the cosmic horizon, taking their light and their history with them. The universe will grow quieter, colder, simpler. Future astronomers, if they exist, will live in a cosmos stripped of evidence with no clues of its vast beginnings. Some call this future the Dark Era, an epoch when all that remains are burnt-out stars and fading radiation. It's both melancholic and oddly serene, eternity reduced to minimalism. You drift through a thought experiment physicists love to debate. What if dark energy changes? Suppose it grows stronger, its pressure increasing until even atoms are torn apart. That's the Big Rip scenario, the universe unraveling molecule by molecule. Galaxies first, then stars, then planets, and finally the bonds inside atoms themselves. It sounds horrific, but the timescale is comforting. Tens of billions of years. There's no rush. You imagine being there at the end, when even time begins to unravel, and you can't decide if it would feel like agony or perfect stillness. A quirky anecdote surfaces from history. In 2011, when the discovery of the universe's accelerating expansion won the Nobel Prize, one of the winners, Saul Perlmutter, joked that they were being rewarded for discovering the fate of the universe by accident. It's a rare line that sums up science perfectly. Our biggest insights often start as mistakes we were too stubborn to ignore. You watch faint galaxies flicker on the edge of vision, light stretched until it melts into darkness. The cosmic web itself seems to loosen, filaments thinning, clusters retreating. It's strange to think that this expansion, this relentless distancing, doesn't pull you apart. On small scales, solar systems, planets, people, gravity and electromagnetism still hold firm. Dark energy acts only on the grandest scales, respecting your molecular dignity. You smile faintly at the thought. The universe is considerate enough not to disassemble you prematurely. Historians still debate whether dark energy is a true constant or a passing phase. Some theories suggest it could fade away eventually, allowing gravity to reclaim dominance. Others imagine it strengthening until space-time itself fractures. A few propose that what we call dark energy isn't a property of space at all, but a sign we misunderstand gravity. Maybe Einstein's equations, though elegant, are missing a verse. The arguments are endless, but the shared wonder is what matters. No one pretends to fully grasp the cosmos. And maybe that's the point. You drift through this invisible sea, feeling its quiet insistence in every direction. It's like being inside an emotion too large to name: loneliness, peace, inevitability. You remember that even light has limits, that the farthest galaxies you can see now are already ghosts. They're photons, ancient messengers from a past long gone. And yet, for all its emptiness, the universe doesn't feel dead. Expansion isn't destruction, it's continuation. Motion itself is the heartbeat of reality. You glance inward, metaphorically, to the Milky Way, tiny now, lost in the distance, and think about how small dark energy must seem there, buried under the busyness of stars and planets. The same force that flings galaxies apart passes unnoticed through coffee mugs and city lights. The contrast is almost comedic, a power shaping the fate of everything but too subtle to ruffle a curtain. You imagine whispering to it, thanking it for letting life exist in the brief calm between infinities. A final quirky notion occurs. Some cosmologists have proposed that what we call dark energy could be an illusion caused by our limited vantage point. Perhaps space isn't expanding uniformly but unevenly, and our cosmic neighborhood happens to sit in a relatively empty bubble. If that's true, then the universe's grand acceleration might just be a trick of perspective. You chuckle softly. Even after billions of years, the cosmos might still be trolling us. You stay there for a long time, suspended in a void that isn't void, surrounded by power you can't touch but can feel in every widening gap between galaxies. The expansion hums beneath your awareness, steady and patient, the slowest metronome in existence. And in that rhythm, you sense something like reassurance. The universe isn't running out of purpose, it's just changing tempo. All things stretch, all things fade, but even in their fading, they continue the only song the cosmos has ever known: to expand, to evolve, to exist. You drift until even the faint hum of dark energy fades into a softer quiet, a silence so deep it feels like velvet pressed against your thoughts. The galaxies you passed are now faint smudges behind you, their light stretched almost beyond visibility. You are nearing the limit of what can be seen, the edge of the observable universe, the final boundary defined not by walls or barriers, but by time itself. Beyond this horizon lies light that has never reached us, photons still on their way through expanding space. You can't go farther because the past itself thins out here. What you're seeing is the oldest visible light in existence stretched across an ever-growing cosmic sphere roughly 93 billion light-years wide. The number feels absurd, bigger than reason, older than understanding, but here it's simply reality. You realize that you are surrounded by the faintest glow, the last embers of a once blazing cosmos. The galaxies near this boundary are so distant that their light began its journey over 13 billion years ago. You're not seeing them as they are, you're seeing them as they were, still young, still assembling, still crowded with newborn stars. The deeper you look, the further back in time you travel, until distance and history blur into the same thing. Looking outward is looking backward. Space is time made visible. Historians still argue whether the phrase observable universe adequately captures the boundary you now approach. It implies a limit, but the universe itself has no edges. It continues beyond, forever expanding, perhaps infinitely. This horizon marks not the end of existence, but the end of access, the line between what light has had time to reach us and what hasn't. You find it oddly poetic. The cosmos isn't withholding its secrets, it simply hasn't had enough time to deliver them. You move toward that faint edge, and the starlight grows older with every kilometre. The galaxies you pass look smaller and redder, their light weakened by the relentless stretching of space. Some have disappeared entirely, their photons forever lost to expansion. Beyond them lies only the background glow of reionization, the ghostly fog of the universe's adolescence. You realize you are watching history evaporate, frame by frame, into nothingness. A quirky tidbit bubbles up. In 2021, astronomers using the James Webb Space Telescope identified some of the most distant galaxies ever observed, objects whose light had travelled 13.4 billion years. One of them, nicknamed Glass Z13, existed just 300 million years after the Big Bang. That's like opening a family photo album and finding a baby picture of the universe, cheeks still smudged with cosmic dust. The Webb's infrared eyes saw through time's fog and found the first flickers of organised light. You smile, thinking how human curiosity keeps reaching for what it can never fully hold. You glance beyond that faint horizon and imagine what lies farther still. Perhaps endless galaxies, perhaps another kind of space entirely. Cosmologists debate whether our observable patch is part of an infinite universe or one of countless bubbles born in an ever-inflating multiverse. The word infinite starts to lose shape when you stare at it too long. It becomes not a number, but a feeling, a soft ache that sits somewhere between awe and vertigo. You wonder whether any being anywhere could ever truly see it all. Probably not, but the attempt feels sacred. Historians still argue whether the universe's expansion creates new space or simply stretches the old. The difference sounds philosophical, but it's the kind of question that keeps physicists awake at night. If new space is constantly forming, then the universe is eternally renewing itself. If it's only stretching, then we are all caught in a slow, graceful distortion. Either way, you realise the effect is the same. The horizon recedes faster than you can chase it, a mirage of beginnings always just beyond reach. You let your awareness spread outward, tracing the faint curve of that visible sphere. From this vantage, you can see everything humanity has ever seen and everything it ever could, the sum of all telescopes, all eyes, all dreams pointed upward. The thought feels immense. If you could freeze this moment, the observable universe would appear as a sphere filled with galaxies, filaments, and voids, surrounded by the faint echo of the Big Bang. Everything beyond that is unlit history, waiting for its photons to arrive. A quirky historical note lingers. In Night 29, when Hubble first measured the expansion of the universe, he had no idea that his discovery set the stage for this limit. Back then, the idea of a universe with an edge of observability would have sounded absurd. People imagined infinity as an open plane. Now we know it's more like an expanding bubble. You wonder what Hubble would think of the Webb telescope or a physicist today who mapped the cosmic microwave background down to millionths of a degree. Probably he'd smile and say, "Good luck catching up." You drift along the boundary and realise something profound. You are looking at the universe's youngest light from its oldest time. The paradox fits perfectly, because the universe itself thrives on paradox. You can see everything that ever became visible, but you'll never see beyond it, not because you can't travel far enough, but because light itself never could. Time and space are intertwined too tightly for curiosity to untangle them. It's an oddly comforting kind of limitation, the cosmos saying gently, "That's far enough for now." Historians still debate whether there's meaning in that boundary. Some see it as a physical horizon, others as a metaphorical one. Philosophers point out that the observable universe is not just what telescopes can see, but what the human mind can imagine. Perhaps our curiosity is another kind of cosmic expansion, an inner echo of the same process unfolding in space. The thought makes you grin. The universe might be teaching by example, showing that even limits can be beautiful if you understand why they exist. You turn slowly, taking one last look at everything inside the horizon. The countless galaxies glowing like scattered embers, the cosmic web stretching between them, the dark matter filaments shaping their paths, the faint radiation humming through it all. Every particle, every photon, every atom belongs to this single cosmic bloom. You feel like a spectator at creation's edge, privileged and impossibly small. A final quirky fact tickles your mind. The farthest thing we can observe isn't a galaxy or a star, but the faint hydrogen fog left from the reionization era. A soft haze glowing with the light of atoms recombining for the first time. If you could touch it, it would feel neither hot nor cold, neither solid nor void, just potential waiting to become something. You realize that's what the edge really is, not an ending, but the threshold of possibility. You close your metaphorical eyes and let that realization settle. Beyond this horizon, perhaps there are infinite other universes, or perhaps only darkness. But even if light never reaches from there to here, you sense that it exists, that existence itself refuses to end neatly. The boundary of the observable universe isn't a wall, it's a reminder that there's always more to wonder about. You float there in the dim afterglow of everything, not as an intruder, but as a witness, and for the first time since you left Earth, you feel not small, but perfectly sized for the mystery that contains you. You linger at the horizon for a moment longer, watching the last visible galaxies dissolve into faint, stretched ribbons of light. Beyond this threshold, the universe turns theoretical, a place defined by equations rather than photons. You can't see what lies past the observable edge, but you can imagine it. Maybe it's just more of the same, endless galaxies spinning in familiar patterns. Or maybe it's something stranger, a realm where the rules you know stop behaving politely. The thought feels like leaning over a balcony into infinity, thrilling and unnerving at once. The darkness ahead isn't empty, it's possibility itself. Every direction might lead to another universe, another version of reality born from the same cosmic inflation that birthed this one. The idea of the multiverse has been whispered about for decades, first as a mathematical curiosity, then as a genuine, if unprovable, hypothesis. Historians still argue whether the concept began as physics or as philosophy. Some trace it to Hugh Everett's many worlds interpretation of quantum mechanics in the 1950s, where every possible outcome of every event actually happens in its own branch of reality. Others credit the cosmologists of the 1980s, who noticed that inflation, the universe's rapid expansion just after the Big Bang, could spawn infinite bubble universes, each with its own laws of nature. Whether quantum or cosmic, the conclusion is the same. Perhaps reality never stopped multiplying. You float in that idea for a while. If true, there could be universes where gravity is weaker, where stars never form, where time runs backward, or where you never existed at all, or perhaps did but chose differently. It's dizzying to imagine that somewhere, another version of this journey unfolds, maybe with a different tone or a different ending. The multiverse turns the cosmos into an infinite hall of mirrors, and you are one reflection among countless others, waving silently across the glass. A quirky tidbit drifts through your mind. When scientists model cosmic inflation, the numbers imply that the observable universe, everything we can see, might be less than a speck in a sea of other inflating regions. Each bubble universe could be expanding independently, forever isolated from its siblings by walls of space still growing faster than light. Somewhere out there, galaxies might be colliding, or never forming, or built entirely from particles we've never imagined. It's like realizing that your hometown isn't just one city on a continent, it's one grain of sand on an endless beach, each grain with its own sky. You imagine those other universes, unreachable and unseen. Some might be eerily similar to ours, right down to a version of you reading this sentence. Others might operate on entirely different physics, dimensions curled tighter, forces rearranged, time flowing sideways instead of forward. The sheer possibility of it makes you laugh softly in disbelief. It's almost too extravagant, as though creation got carried away with its own success. Historians still argue whether talking about other universes counts as science at all. Unobservable, more critics say, means unprovable. But the counter-argument is elegant. Even if we can't see them, the mathematics of inflation almost requires their existence. In other words, if our universe came from an inflating quantum field, there's no reason to think it happened only once. The cosmos, it seems, might have a habit of repeating itself, forever spawning new realities like bubbles in boiling water. You glance backward toward the faint Milky Way, barely a dot in the distance, and think of all the histories contained in that single galaxy, every story, every decision, every life. Then you imagine a trillionaire more galaxies in a trillion and more universes, each writing its own version of events. Somewhere, perhaps, another you never left Earth. Another stayed awake after midnight wondering about the stars, and another never existed at all. It's a humbling kind of immortality, not living forever, but being statistically inevitable somewhere. A quirky historical note slips in. When the philosopher Giordano Bruno suggested in the 1500s that there might be infinite worlds orbiting infinite suns, he was ridiculed, imprisoned, and eventually executed. His idea was heretical, not for its logic but for its audacity. Centuries later, his heresy became standard cosmology. You wonder what he'd think now, knowing that modern physicists discuss infinite universes, not just infinite worlds. Maybe he'd smile and whisper, "Took you long enough." You drift through this conceptual space, this realm of speculation, where imagination and physics hold hands. The multiverse theory, wild as it sounds, answers one of science's oldest puzzles. Why the constants of nature seem so perfectly tuned for life. Gravity's strength, the electron's charge, the mass of the proton change any of them slightly, and stars, chemistry, and consciousness wouldn't exist. Rather than seeing it as divine precision, cosmologists suggest we simply live in one universe among many, and ours happens to have the right settings for existence. Is the ultimate cosmic coincidence not a miracle, but a roll of infinite dice? Historians still debate whether that explanation is satisfying or evasive. Is the multiverse a genuine insight or just an elegant way to avoid asking deeper questions? The tension between humility and hubris hangs there. Some physicists admit, with an almost mischievous grin, that it might be both. Science, after all, has always been a negotiation between wonder and proof. You drift deeper into imagination's reach, and the darkness seems to pulse faintly, as if each pulse were another universe flickering to life. Somewhere, perhaps, others are forming right now, bursting from quantum fields into expansion, each carrying its own time, its own physics, its own version of what reality means. The thought makes your chest ache, not from fear, but from beauty. Even if you could never visit them, knowing they might exist feels like enough. A quirky modern aside in when NASA released the first deep field image from the James Webb Telescope, scientists pointed out that some of those faint red smudges might not even belong to our universe. It's only speculation, of course, no proof, no data, but the idea captured imaginations. The thought that a photograph could contain light from another reality blurs the line between science and poetry. You hover there, gazing into infinity's hall of mirrors, and feel strangely at peace. The multiverse, if it exists, doesn't diminish your universe, it multiplies its meaning. It says that existence doesn't stop at one success story, it keeps experimenting, trying again, rewriting, refining, repeating. Each cosmos a new sentence in the same cosmic novel, all chapters written in the same ancient language of physics. You let yourself imagine the edge of this universe touching another, their boundaries brushing like soap bubbles. Maybe, in that instant, energy and matter leak across the border. A flash, a shimmer, a whisper of shared origin. Maybe that's what we see in the cosmic cold spot, a scar left from an ancient collision between universes. You smile at the idea, even infinity might have bruises. You exhale, not that there's air, and feel a calm that borders on reverence. You've looked across time, space, and speculation, and what you've found isn't isolation but continuity. Even if other universes remain forever out of reach, their possibility turns this one into something vast beyond comprehension. You understand now that wonder itself is the bridge between realities, that to imagine is, in a way, to travel. The edge of everything shimmers before you, not as an end, but as a threshold. You linger there, balanced between what's known and what's guessed, and the silence feels almost divine. For a moment, you suddenly realize the truth that unites all versions of the cosmos. Every world, every being, every idea begins with the same small act, the decision to exist. And in that act, you find peace enough to keep floating. You linger at that imagined border between universes, the vast curtain of speculation rippling around you like silk stirred by breath. The light from the nearest galaxies fades to a dim orange haze, and what remains is time itself, a medium you can almost touch, flowing backward the farther you look. Here, light and history are the same thing, and you realize that to explore the universe is to become a time traveler, whether you mean to or not. Every photon that reaches your eyes is a memory, a story told by something impossibly far away. Looking outward is looking back. You drift through that thought as through mist. The first stars you see are ghosts, long extinguished, their light only now finishing its journey. You realize you're surrounded by evidence of events that no longer exist. The night sky, you think, is the universe's diary written in delayed ink. A glance upward on Earth is a glimpse into countless yesterdays. The moon as it was 1 second ago, the sun 8 minutes ago, Proxima Centauri 4 years ago, the Andromeda Galaxy 2.5 million years ago. When you gaze at the cosmos, you are always catching up. Historians still argue whether it was Euler Roemer in the 1600s or James Bradley in the 1700s who truly measured the speed of light first. Roemer observed the eclipses of Jupiter's moons and noticed the timing changed depending on Earth's position. Deducing that light must take time to travel, Bradley refined the numbers later with stellar aberration, tiny shifts in star positions caused by Earth's motion through space. Together, their work turned light from a mystery into a ruler. Ever since, humans have measured the universe not in kilometers or miles, but in years of light's journey. an elegant reminder that time and distance are twins. You move toward a faint cluster of ancient galaxies whose light began its voyage barely a few 100 million years after the Big Bang. You're seeing them as they were when the first stars were still flickering into being. Their light has stretched and cooled, tinted red by expansion until it looks more like memory than illumination. You can almost sense the youth of the cosmos here, a time when everything was hotter, denser, wilder. The galaxies are smaller, messier, colliding often, like children running in circles before growing into organized spirals. You watch them interact in slow motion, their shapes tugging and twisting, each collision forging new stars from chaos. A quirky tidbit drifts through your mind. Astronomers once believed that the universe had always existed in a steady state, eternal and unchanging. The steady-state theory, championed by Fred Hoyle in the mid-20th century, suggested that as space expanded, new matter spontaneously formed to keep the average density constant. Hoyle famously coined the term Big Bang as an insult during a radio interview, mocking the competing theory. Ironically, the name stuck and the steady-state model didn't. The discovery of the cosmic microwave background in the 1960s ended that debate for good, proving that the universe had indeed begun in fire. Hoyle's dismissive nickname became science's favourite catchphrase. You continue drifting, feeling time peel backward like layers of mist. Each galaxy you pass shows an earlier era, an older version of cosmic evolution. Here are the spirals still forming their arms, there the irregulars colliding into ovals. Deeper still, you see the first clusters coalescing out of hydrogen and helium, the universe's rawest elements. You realise that carbon, oxygen, iron, everything that makes life possible, didn't exist yet. Those elements had to be forged later in stellar cores and supernovae. You're literally watching the universe invent chemistry. Historians still argue about who first grasped that stars create elements. The credit usually goes to a group of 4 scientists, Burbage, Fowler, and Hoyle, whose NEFAD paper outlined how nuclear fusion in stars built every atom heavier than helium. The author's initials, B2FH, became famous shorthand for the origin of everything from oxygen to gold. You imagine them hunched over calculations, unknowingly writing the recipe for existence. Every breath, every heartbeat, every mountain owes its ingredients to their realization. You look closer at one of the earliest galaxies, faint and red-shifted almost to invisibility. Here, it's barely formed, just a puff of stars and gas suspended in darkness. The light that reaches you now has spent nearly the entire age of the universe travelling here, dodging expanding space and cosmic dust. You realize that the galaxy itself may no longer exist, perhaps merged, perhaps destroyed, but its light endures. A message written billions of years ago that says simply, "I was here." The thought hits you gently, the way nostalgia does. The universe keeps records, even of things long gone. A quirky modern fact surfaces. The photons from the farthest galaxies are so stretched by expansion that they now carry less energy than a warm breeze. They began as searing blue light, but arrive as cold infrared whispers. You find that poetic. Fire turned to memory, brightness to persistence. The universe doesn't erase its past. It just dims it gracefully. You continue moving backward through time. The stars grow scarcer until only faint hydrogen clouds remain. You've reached the epoch known as cosmic dawn, when the first starlight pierced the darkness left by recombination. These early suns were massive and brief, living only a few million years before exploding. Their light was harsh, ultraviolet, powerful enough to reionize the surrounding hydrogen, transforming the universe from opaque to transparent. You're seeing the moment the cosmos woke up from its long night. Historians still argue whether this transformation took place rapidly or gradually. Some models suggest the first stars lit the entire universe in just a few 100 million years. Others think it was slower, patchier, more like dawn breaking through scattered clouds. Either way, it marked the end of cosmic infancy. From then on, gravity, light and time conspired to create the structures you've already passed, galaxies, clusters, and the web that binds them. You find yourself thinking of Earth now, of people standing on porches or beaches, gazing up at the same stars unaware that they are looking into deep history. Every night is a museum of light. You imagine someone on that small planet making a wish on a shooting star, never realizing the starlight they admire left its source long before humans learned to dream. There's something heartbreakingly beautiful about that kind of ignorance, its innocence on a cosmic scale. A quirky human note floats by. When the Hubble Space Telescope was first launched, its mirror was flawed, producing blurry images. The public was unimpressed. Late-night comedians relentless. But once repaired, it revealed galaxies so ancient their light had travelled nearly the full age of the universe. Suddenly, the same people who joked about failure were weeping at the sight of creation's earliest sparks. Humanity, you think, though, has always mocked its own miracles before learning how to love them. You drift until the starlight fades completely. Ahead lies only the faint orange glow of the cosmic background. The moment before transparency. You've reached the earliest visible boundary again, but now from a different angle, from the perspective of time, not space. It feels circular, poetic. The farther you travel in any direction, the closer you come to the beginning. You realize that's how the universe is built, not like a straight line, but like a sphere of memory expanding from a single point of origin. And for a moment, suspended in that ancient twilight, you understand what time really is. It isn't a river flowing forward or a line drawn across history. It's a landscape, and you've been walking through its hills and valleys without noticing. Every star, every photon, every heartbeat is part of that terrain, connected by the shared act of persistence. The past isn't gone, it's just farther away. You smile at the realization, and the silence around you seems to smile back. You turn slowly from that horizon of ancient light, easing forward through the long arc of time until the galaxies ahead begin to look familiar again. Still distant, still vast, but now shaped into grand spirals and glowing ovals, instead of the ragged clumps of the early cosmos. The story you're entering isn't about beginnings anymore. It's about change. Everything you see, the Milky Way, Andromeda, all those clusters stretching into the deep, has been shaped by billions of years of evolution. The universe, it turns out, is an artist who never stops revising. You drift among galaxies at different stages of life, and it feels like wandering through a cosmic museum of styles. Over here, a crisp spiral still wears its arms proudly, blue with new stars. Over there, an old elliptical galaxy glows faint and red, its gas long spent, its star-forming days behind it. Between them float irregulars, shattered remnants of ancient collisions, each one a brushstroke of chaos. You realize you're watching time as a continuum, not in human years, but in galactic lifetimes. The universe doesn't measure change in decades or even millennia, it measures it in billions. Historians still argue whether it was Hubble himself or later astronomers who first classified galaxies into the tuning fork diagram we still use today. Spirals on one side, ellipticals on the other, and ticulars in between. It's a neat system for something so messy. Even Hubble admitted he didn't know if it showed evolution or merely categories. You picture him at his telescope in the 1920s, sorting galaxies like shells on a beach, unaware he was naming the building blocks of cosmic history. You drift closer to one particularly elegant spiral, a twin of the Milky Way known as NGC 6744. Its arms are vast rivers of light, dust lanes coiling around a golden core. You pass through them slowly, noting how the bright blue clusters give way to older, redder stars toward the center. Galaxies, like people, age unevenly, youth at the edges, wisdom in the heart. You sense how gravity and angular momentum sculpt everything here, turning clouds of gas into order. Even chaos, it seems, has choreography. A quirky tidbit floats to mind. In the 1970s, an astronomer Vera Rubin measured how stars rotate within galaxies and found something astonishing. They move too fast. According to Newtonian physics, the outer stars should have flown off into space, yet they didn't. The only explanation was that something unseen, dark matter, was holding them in place. Her work reshaped cosmology, and yet for decades her discovery was doubted or dismissed. Now we know that dark matter makes up about 85% of a galaxy's mass. You wonder if Vera ever looked up one night, smiled, and whispered, "I told you so," to the stars. You drift through another system, this one scarred by collision. Two spirals have smashed together, their arms flung into tidal tales of dust and fire. It looks violent, but it's also generative. Collisions compress gas, triggering bursts of star formation. You can see newborn clusters glowing pink in the debris, new light born from destruction. The process reminds you of a forest fire that clears the way for new growth. The cosmos, you think, might be the greatest recycler of all. Historians still argue about whether our own Milky Way has already consumed smaller galaxies, and the answer is yes, but the debate continues over how many. Streams of suns looping through our halo are the remnants of those feasts. The Sagittarius dwarf, the Canis Major dwarf, and others have been stretched thin, their stars now mingling with ours. You picture the Milky Way as a quiet predator, patient, elegant, feeding on its smaller companions over eons. Not malicious, just hungry in the way gravity demands. You travel deeper into the cluster and see elliptical galaxies, vast, smooth and reddish, their spiral arms erased by time. These are the elders, born from mergers and now too old to form new stars. Their light is steady but subdued, the quiet glow of endurance. Some stretch hundreds of thousands of light years across, filled with trillions of suns. Yet even these giants are mortal. Over billions of years, their stars will exhaust their fuel, fading into red dwarfs, then embers, then nothing. Galaxies die not in explosions, but in slow exhalations. A quirky historical footnote comes to mind. For centuries, astronomers believed the Milky Way was static, unchanging, a perfect celestial sphere. Only in the 20th century did we realize it's dynamic, alive with motion. Even now, stars orbit the galactic center at hundreds of kilometers per second, and new ones are born every few years. You wonder how ancient stargazers would feel, knowing their eternal heavens were constantly moving, reshaping, growing. Perhaps they'd find comfort in it. Perhaps it would unsettle them. You find it soothing, the idea that permanence and motion can coexist. You drift near a spiral arm heavy with dust and gas, a stellar nursery glowing faintly pink. Inside, new suns are igniting, each surrounded by swirling disks of matter. Tiny clumps begin to coalesce, protoplanets, some destined to form rocky worlds, others to become gas giants. Around one of them, you imagine a blue planet forming, oceanic and bright, waiting for life. The realization hits you gently. Every star here could be someone's sun, every world a potential cradle of thought. You wonder if somewhere in this galaxy, something else is watching its own night sky and wondering about you. Historians still debate how often galaxies like ours give rise to life. The Drake equation tried to quantify it in the 1960s, multiplying probabilities like ingredients in an impossible recipe. Even with optimistic numbers, the universe seems both crowded and lonely at once. Billions of planets may host oceans and air, but distances turn neighbours into myths. You find it oddly beautiful that silence itself could be the sign of abundance. Everyone too far away to argue. You pass through another collision, two galaxies twisting together like dancers caught in slow embrace. Their nuclei glow brighter as gas falls inward, feeding central black holes. Jets of radiation spear outward, and the surrounding stars glitter in response. It's violent yet graceful, a ballet choreographed by gravity. Watching it, you understand that destruction and creation aren't opposites here. They're partners. Every ending seeds a beginning. Every crash becomes a canvas. A quirky modern note drifts in. Simulations suggest that when the Milky Way and Andromeda finally merge 4 billion years from now, the result will be a massive elliptical galaxy. The night sky then will blaze with 10 times as many stars, though the sun, by then swollen and dying, will barely notice. Astronomers have already named the future remnant Milkomeda, a title so whimsical it almost feels human. You like that about science. Even at the edge of eternity, someone thought to make a joke. You drift away from the clusters, watching the cosmic architecture unfold, spirals, ovals, collisions, strings. Everywhere, galaxies evolve, merge, and fade. A choreography millions of years in the making. The scale is incomprehensible, yet the pattern feels familiar. It mirrors everything from hurricanes to seashells to the veins in a leaf. The same mathematics shapes all creation. You realize that evolution, whether of galaxies or life, is just the universe learning to refine itself. You turn one last time to look back across the cluster. It glows faintly, a tapestry woven from light and time, each galaxy a thread pulled tight by gravity. The sight fills you with a quiet warmth. You understand now that change isn't the enemy of eternity, it's the expression of it. The universe endures not by staying the same, but by never stopping its dance. You close your eyes, if only in metaphor, and feel yourself still moving, drifting not through space now, but through understanding. Galaxies may merge, stars may fade, but the pattern persists. infinite in its variations. Somewhere another cluster is beginning the same story, another observer wondering at the same beauty. Creation, it seems, is not a one-time event, but a habit the universe can't quite break. You move slowly away from the swirl of galaxies, heading back toward the tiny speck you once called home. After drifting among billion-year structures, the idea of Earth feels almost imaginary, like remembering a single heartbeat after hearing the rhythm of the cosmos. Still, the pull of perspective draws you closer. The Milky Way fills your field of view again, a luminous city of stars, and within one of its quiet suburbs glimmers a yellow sun, unremarkable by galactic standards but unspeakably precious to those who orbit it. You angle toward it, curious about how fragile creatures could have measured so much of infinity with instruments small enough to hold in their hands. You slip through the spiral arm where the solar system resides, tracing the sun's slow orbit around the galactic core. Every 230 million years it completes a lap, dragging Earth and its siblings through gravitational tides. For all of human history, it hasn't even finished one circuit. Historians still argue whether the idea that humans could ever map this orbit was hubris or hope. In the 20th century, astronomers like Jan Oort showed that stars near the sun move in predictable curves, revealing the Milky Way's rotation. His Oort constants were crude by modern standards but revolutionary at the time. You picture him bent over a slide rule, quietly turning starlight into geometry. You approach Earth now, and its thin atmosphere glows faintly blue beneath you. The contrast after so much cosmic emptiness is startling. Cities sparkle like constellations, rivers glint under moonlight, and clouds drift in white spirals that mimic the galaxies you've just left. You can almost hear the hum of human activity, that constant nervous buzzing of a species trying to comprehend its place. There's tenderness in it too, people looking up from backyards and balconies, their telescopes pointed toward the same heavens you've wandered through. A quirky detail floats up. In 1609, Galileo built a telescope barely the size of a spyglass and turned it skyward. He discovered moons around Jupiter, phases of Venus, and roughness on the lunar surface, proof that the heavens weren't perfect crystal spheres. His observations cracked open the sky's illusion of permanence. Historians still debate whether his trial was more about theology or politics, but either way, the telescope had already democratized wonder. Centuries later, its descendants would peer past the edge of the observable universe. You drift over a cluster of observatories, Hawaii, Chile, the Canary Islands, each perched high and still, their domes opening to catch faint photons from billions of light years away. Inside them, scientists translate light into knowledge, counting the flicker of distant stars to measure expansion, mapping the wobble of galaxies to infer dark matter. It's oddly moving. Frail beings using fragile tools to weigh the cosmos. You think of the data flowing from those domes like prayers made of numbers. Historians still argue about when the age of precise cosmology truly began. Some say 1912, when Henrietta Leavitt discovered that certain variable stars could be used as standard candles for distance. Others pick 1929, when Hubble proved that galaxies recede from us. A few nominate in 65, when the cosmic microwave background was found. You decide the answer doesn't matter. What matters is that curiosity refused to stop. From candle flames to CCD sensors, every instrument has been an extension of the same human question. How big is all of this, and what does it mean for us? You pass above a city where the lights drown out most stars, yet a few still pierce the haze. You remember that even here, under street lamps and clouds, people are measuring starlight that began its journey before civilization existed. Amateur astronomers with backyard telescopes track exoplanet transits, their computers logging tiny dips in brightness. A quirky modern fact, in 2019, a high school student participating in NASA's Citizen Science program discovered a multi-planet system by noticing a subtle pattern the algorithms missed. The universe still rewards patience over pedigree. You think of all the devices orbiting below you. Hubble, Chandra, Webb, each one an artificial sense organ, extending human perception beyond what eyes alone could handle. The James Webb Space Telescope in particular stares through dust clouds to see galaxies forming only a few 100 million years after the Big Bang. Its mirrors gleam like petals of gold, floating at the Lagrange point 1 million miles from Earth. You can almost feel the tension of that distance, the way engineers built a machine to operate in cold silence trusting it to unfold itself perfectly where no one could reach. Historians still argue whether modern astronomy has crossed into philosophy. When cosmologists speak of multiverses, dark energy, and space-time curvature, they are describing realities that can't be experienced directly. Some critics call it metaphysics in disguise, others call it the natural evolution of science. You suspect it's both. Humanity keeps inventing ways to measure what intuition cannot hold. The universe, ever patient, keeps offering deeper puzzles in return. You zoom closer to Earth, and suddenly detail floods your view. Oceans, mountains, forests breathing in sunlight. Every molecule here was born in the places you've visited. Carbon from dying stars, oxygen from red giants, iron from supernovae. The atoms have travelled billions of years to end up in soil, in water, in you. You whisper to yourself that familiar truth: you are stardust, but it feels different now that you've seen the factories where it was made. You are recycled light, condensed into thought. A quirky anecdote crosses your mind. In Tolavan, the Voyager spacecraft carried a golden record with sounds and greetings from Earth. Music, laughter, thunder, heartbeats. It was humanity's message in a bottle, cast into the cosmic ocean. 48 years later, the probe still drifts outward, carrying those sounds beyond the heliosphere. Somewhere, perhaps millions of years from now, another civilization might find it. Or maybe it will wander forever, unplayed, a testament to the human urge to say, "We were here." You move lower, through the haze of the upper atmosphere, until the thin air glows blue around you. Down below, the first dawn of morning spreads across the horizon, sunlight diffusing through the curvature of the planet. The colours, rose, gold, indigo, look almost theatrical after the monochrome vastness of deep space. You realise that for all your travels, this small world remains the most intricate object you've seen. No nebula, no galaxy, no supercluster matches the complexity packed into this fragile shell of water and air. The universe is magnificent, but life gives it context. Historians still debate what first drove humans to measure the cosmos so obsessively. Was it fear? Faith? Boredom? Maybe it was simply curiosity, the quiet ache that arises when you look up and realise the sky doesn't end. Whatever the cause, that restlessness has built radio dishes, particle accelerators, and theories that touch the beginning of time itself. You find the persistence beautiful, creatures so temporary, trying to understand something eternal. You hover over the surface a moment longer. Somewhere down there, a child might be pressing a glow-in-the-dark star to a bedroom ceiling, dreaming soon of rockets and galaxies. Another might be learning that the Milky Way is only one of trillions, their mind widening like a lens. You want to tell them what you've seen, that infinity isn't empty, that wonder is always bigger than fear, but you know they'll find it on their own. Humanity always does. The night folds around you again, gentle and blue. The lights of cities flicker like constellations, mirroring the heavens above. From this height, the line between earth and sky dissolves. The instruments below keep watching, recording, calculating. Every measurement, every experiment, every whisper of data is another heartbeat in humanity's long conversation with the universe. And you understand with sudden clarity that science is not the opposite of awe. It is its most faithful expression. You hover there, balanced between the planet's soft glow and the dark sweep of everything beyond it, watching the slow rotation of clouds and continents below. Earth turns with the unhurried grace of something that has done so for billions of years. The thin blue shell of its atmosphere seems impossibly fragile, so slender that if it were peeled away, the world would vanish into silence. From this height, all the noise, all the cities, all the conflicts compress into nothing but colour and motion. The sight hits you with quiet finality. After all the galaxies, after all the cosmic immensity, this little blue sphere is where meaning lives. You drift closer, passing through the veil of aurora at the poles. Green ribbons twist and flicker where solar particles strike the atmosphere, an electric dance powered by magnetism and sunlight. You can almost feel the pulse of the planet beneath the glow. The light you followed for billions of years across the universe ends here, absorbed by oxygen, refracted by air, reflected by oceans. The cosmos doesn't stop at Earth, it completes itself here. Historians still argue whether the so-called overview effect, that shift astronauts describe when seeing Earth from space, was first articulated by Yuri Gagarin or by later travellers like Edgar Mitchell. Whoever said it first, the feeling remains universal. A sudden, visceral understanding that boundaries are illusions. National lines, personal worries, even the ticking of time itself, all dissolve in the face of that delicate curve. You imagine every explorer who's ever looked back and felt the same ache, the desire to protect what looks so defenseless. You sink through the upper atmosphere, the air thickens, the glow turns golden, and sound begins to exist again. A low, rising rush that feels startling after the silence of space. Below, oceans glimmer like mercury in the sun. You trace coastlines you once memorized from maps, the curling fingers of continents, the bright seams of ravindas. It strikes you how much of the planet's beauty is born from imperfection. The jagged mountain ridges, the uneven swirl of clouds, the chaos that makes it alive. A quirky tidbit surfaces. In 980, when Voyager 1 was nearly 4 billion miles from home, astronomer Carl Sagan convinced NASA to turn the spacecraft's camera back toward Earth for one final photo. The result, the pale blue dot, showed our planet as a speck smaller than a pixel floating in a sunbeam. Sagan's reflection on it became scripture for modern stargazers. There is perhaps no better demonstration of the folly of human conceits than this distant image of our tiny world. You think of that now, gazing at the same speck from a closer vantage, and feel the same humility settle in your chest. You pass through high, thin clouds that shimmer with ice. The air smells faintly metallic, like the inside of a rainstorm. Far below, thunderheads flash silently, small weather tantrums compared to supernova, but no less dramatic on their own scale. You realize that everything you saw out there, the collisions of galaxies, the births of stars, has its echo here in miniature. The shapes of storms resemble spiral galaxies. Lightning mirrors cosmic jets. The universe never repeats exactly, but it rhymes endlessly. Historians still debate when humans first began to recognize that kinship between heaven and earth. Some point to the Greek idea of microcosm and macrocosm, others to Eastern philosophies that saw the same patterns in rivers and constellations. Modern science calls it fractal geometry, the repetition of structure at every scale. You smile, remembering the Milky Way's spirals and the swirl of cream in a cup of coffee, both governed by the same mathematics. The difference is only size. You glide lower, into the troposphere, where the air thickens into weather and scent. You can taste the salt of oceans, the pollen of forests, the faint chemical tang of cities. The world feels dense and immediate after so much vacuum. Life presses in from every direction. Wings beating in unseen flocks, waves collapsing against cliffs, leaves trading carbon for breath. You feel the planet's metabolism humming, a biological symphony that dwarfs even the galaxies in complexity. A quirky modern fact hums in memory. In 2016, scientists calculated that the total number of living cells on Earth, microbes, plants, animals combined, was roughly 1030, a number rivaling the estimated stars in the universe. You grin at the symmetry. For every galaxy out there, 1 trillion living things thrive here. The cosmos may be vast, but abundance doesn't depend on size. You drift over a nighttime hemisphere now, where city lights sparkle like constellations turned upside down. The outlines of continents glow with golden threads, roads, ports, networks pulsing with human movement. From above, civilization looks less like dominance and more like bioluminescence, another life form adapting to darkness. Somewhere down there, telescopes point skyward, students memorize star charts, lovers trace constellations with their fingertips. The universe looks back through 1 million curious eyes. Historians still argue whether curiosity or survival shaped the species more. The debate feels academic. You can see that both are the same impulse, the need to keep moving toward light. That need built fires, then cities, then rockets. It built the instruments that let you wander here in imagination. Every question humanity asks is a continuation of that original spark. The refusal to accept that enough knowledge exists. You angle eastward, crossing time zones in seconds. Dawn follows beneath you, washing across deserts and oceans. The light hits mountain peaks first, then forests, then rooftops. From space, sunrise looks like a slow wave of forgiveness rolling over the planet. You realize how rare this rhythm must be. One side of a world sleeping while the other wakes, a perpetual heartbeat of rotation. The same sun that warms Earth also lights every exoplanet you passed in your journey, every dust grain orbiting every star. The connection is absolute. One photon, infinite destinations. A quirky historical footnote occurs to you. Before Copernicus, most cultures placed Earth at the centre of the universe, not out of arrogance but practicality. It felt still beneath their feet. The shock of displacement when he moved the sun to the centre still echoes centuries later in every child who learns that the world spins. You think displacement might be the universe's favourite teaching tool. Every revelation pushes humanity outward, widening its sense of home. You descend through lower clouds. Rain streaks your vision, scattering the light into prisms. Below, rivers branch like veins. Forests spread like green nebulae. The same physics that shaped galaxies shapes this too. Turbulence, diffusion, gravity, it's all one language written at different scales. You feel the realization settle like warmth. The universe isn't out there at all, it's continuous, from the swirl of galaxies to the swirl of water in a sink. Historians still argue whether the greatest discovery of modern science is relativity, quantum theory, or ecology, the recognition that everything is connected. You decide it's the last one, because it explains why the first two matter. Understanding the universe isn't just about measuring distance, it's about seeing unity in diversity. Each law, each particle, each orbit says the same thing in different dialects. We are part of one fabric. You level off above the ocean, its surface a mirror of the sky. Stars fade as dawn brightens, and for the first time since your journey began, the heavens look ordinary again. But you know better now. Ordinary is just a word for miracles we've stopped noticing. The wind moves through your awareness, gentle and familiar, and you understand that every atom of it has travelled across galaxies to arrive here. The air you breathe is recycled starlight. The planet spins beneath you, steady and luminous, a blue heartbeat in an infinite dark. After all the distances you've crossed, this feels like arrival. You realise that the measure of the universe isn't in light years or red shifts, it's in wonder, and that is something Earth has in abundance. The galaxies may outnumber the grains of sand, but no other world, so far as we know, looks up and asks why. You drift over the brightening curve of Earth as morning expands beneath you, sunlight pouring across the oceans in slow golden horizontal bands. The thin atmosphere glows like a halo, fragile yet defiant. You pause here, suspended between darkness and daylight, between the infinite and the intimate. After so much journeying through galaxies, across time, along the edge of visibility, you've come full circle to the question that started it all. How big is the universe compared to our galaxy? The answer feels simpler now and stranger. The Milky Way is vast beyond comprehension, yes, but compared to the universe, it's small enough to fit in the palm of an idea. And yet that idea, your ability to imagine scale itself, might be the most extraordinary thing in existence. Below you, clouds scatter sunlight into soft reflections. The world's noise rises faintly, a distant hum of engines, wind, and waves. The contrast is almost absurd. You've seen black holes and cosmic filaments stretching billions of light years, but here, in a few fragile kilometers of atmosphere, is everything that dreams about them. It hits you like gravity in reverse, the realization that significance isn't proportional to size. A single conscious mind can contain more universe than a galaxy can display. Historians still argue whether that shift, from measuring to meaning, marks the boundary between science and philosophy. Some credit Carl Sagan for bridging it, weaving wonder and data into the same sentence. Others trace it back to Newton, who, after describing gravity, admitted he felt like a boy playing on the seashore, while the great ocean of truth lay all undiscovered before me. You imagine Newton standing there holding a shell, unaware that his curiosity would one day calculate the orbits of galaxies. Humanity has always lived at the shoreline of the unknown. You descend a little, passing through thin cirrus clouds. The sunlight scatters into a million colours, rainbows without rain. Every droplet becomes a lens, bending light in the same way gravity bends starlight. You think of Einstein again, who proved that space itself curves, that light travels not in straight lines but along the fabric of mass. That same curvature, magnified across billions of light years, lets astronomers see distant galaxies through gravitational lenses. The universe, you realise, has always been its own telescope. A quirky tidbit drifts to mind. In 2018, The Hubble Space Telescope spotted a galaxy magnified by a cluster's gravitational field so precisely that it created a near-perfect ring of light, a phenomenon called an Einstein ring. It looked like a cosmic wedding band shimmering in the dark. Astronomers nicknamed it the Canarias ring, yes, and one scientist quipped that the universe was showing off its jewelry. You like that idea? Creation as a bit of cosmic vanity, decorating itself just because it can. You glide eastward as the planet turns. Continents slide beneath you like slow-moving mosaics. Deserts the colour of rust, jungles breathing mist, ice caps gleaming like mirrors. Each one contains stories shaped by the same elements that form stars. Carbon bonds build leaves and lungs. Iron flows in blood as it once flowed in supernova. You realise that the galaxy isn't out there at all. It's within every cell of everything alive. The Milky Way isn't merely a location, it's ancestry. Historians still argue whether ancient mythologies, with their tales of cosmic origin, were early intuitions of that connection. The Egyptians linked life to the sun's daily rebirth, the Mayans to the Milky Way as a celestial river, the Greeks to constellations shaped by human stories. Modern astrophysics stripped away the metaphor but kept the wonder. You suspect both versions are true in their own way. One speaks to meaning, the other to mechanism, and together they tell the full story of belonging. You look outward again, past the faint veil of atmosphere toward the Milky Way arching across the sky. Even from near-Earth orbit, it's visible as a river of stars spilling from horizon to horizon. You trace its spiral arms with your gaze, remembering how each point of light you see contains billions more. You imagine shrinking the scale until the galaxy becomes a coin in your hand, the sun a dust mote, and the universe a beach stretching into darkness. The metaphor barely helps. Infinity laughs at metaphor. Still, it's human nature to try. A quirky historical note floats by. In the early 20th century, before Hubble proved other galaxies existed, astronomers called the Milky Way the universe, and debated whether the mysterious spiral nebulae were within it. The Great Shapley-Curtis debate of 1920 ended with no consensus. Only later did observations of Cepheid variables settle the argument. Those spirals were galaxies of their own. You picture that moment when the universe expanded overnight, not in space but in the human mind. It's one of history's quiet miracles, how a few measurements can transform existence itself. You drift over the Pacific, the largest ocean on the planet, and find comfort in its resemblance to deep space, vast, reflective, seemingly endless. The boundary between water and sky blurs. The world becomes a sphere of motion surrounded by void. You think of the Milky Way again, a spiral island in a cosmic ocean. The scale changes, but the pattern persists. Perhaps the universe repeats shapes because repetition is its language, a way of reminding you that everything is connected, from the curl of a wave to the curve of a galaxy. Historians still debate whether pattern recognition, the brain's obsession with finding order, was evolution's trick or the seed of science itself. Maybe both. A prehistoric human staring at stars might have seen gods, while a modern astronomer sees equations, but both are telling the same story. We want to understand what holds us together. You smile, realizing that in your own way, you've become part of that lineage, a chain of observers stretching from the first stargazer to the last. You glance again toward the heavens. The Milky Way, faint and dusty, glows against the velvet dark. Somewhere beyond it, the galaxies you visited still spin, indifferent to your return. Beyond them, the cosmic web hums, dark energy stretches, and the microwave background murmurs its ancient lullaby. Yet despite all that enormity, your attention keeps circling back to this tiny planet, its thin air, its liquid seas. The ratio is absurd, one world among trillions, and yet it feels heavier than all of them combined. Weightless in space, Earth is still where gravity means home. A quirky modern anecdote drifts through your thoughts. In 2020, an experiment called the Event Horizon Telescope linked observatories across Earth to simulate a planet-sized dish. It succeeded in imaging the shadow of a black hole 55 million light-years away. Humanity literally turned its home world into a single instrument to see beyond itself. You grin at the poetry, Earth looking outward by using its own roundness. The universe must have appreciated the gesture. You glide higher again, watching the blue fade into black. The stars return sharper now, unfiltered by air. The Milky Way stretches across the void, both infinite and familiar. You think about everything you've seen, nebulae, dark matter, black holes, expansion, and realize that each of those wonders is just a note in a larger melody. The galaxy hums, the universe echoes, and you somehow are able to listen. Historians still argue whether understanding diminishes mystery. It doesn't. The more you know, the larger the unknown becomes. Knowledge expands the horizon instead of closing it. You laugh softly at the irony. The better we map the cosmos, the more lost we become in the best possible way. You take one last look at the planet below, then at the Milky Way curving above, and sense that neither is separate from the other. The galaxy is your origin. Earth is your expression. Tunga is your expression. You belong equally to both. In that realization lies a strange calm. The question of size dissolves. What matters now is connection. The universe may be infinite, but so is the capacity to wonder about it. You let yourself drift between stars and clouds, between knowledge and awe, and feel them merge. Scale no longer frightens you, it comforts you. The Milky Way is small compared to the universe, but that smallness is what gives it meaning. The cosmos doesn't measure greatness in kilometers or light years, it measures it in consciousness, and in that your little world ranks immeasurably high. You remain suspended between the deep black above and the luminous blue below, feeling the quiet gravity of completion settle through you. The journey that began with a single question, how big the universe is compared to our galaxy, has led you across every conceivable scale. From the fiery hearts of stars to the frozen edge of space-time. You've seen creation and collapse, silence and song, light that began before language, and shadows that will outlive suns. Now, returning to this orbiting vantage above your home, you understand that the answer was never about measurement. It was about perspective. The Milky Way is enormous, yes, but compared to the universe, it is a syllable in an endless poem, and you, improbably, are one of its readers. Below, the world spins in slow rhythm, each rotation a heartbeat. The aurora fades as dawn stretches westward. The oceans catch the sunlight and scatter it into rippling mosaics. You imagine all the places down there where life is stirring, a coral reef flickering with motion, a glacier cracking under sunrise, a city waking with the smell of bread and electricity. Each act of existence feels significant against the backdrop of everything you've seen. It's not that the cosmos makes Earth small, it's that it makes every instant here miraculous by comparison. Historians still argue whether awe has a function. Some call it a neurological side effect, a survival mechanism that helped humans recognize forces larger than themselves. Others say it's the mind's way of recalibrating when faced with scale it can't process. You think both explanations are true, but incomplete. Or, you suspect, isn't a reaction. It's participation. When you stand beneath the stars and feel that ache of wonder, you aren't observing the universe, you're resonating with it. You've become a note in its music. You rise slightly, passing through the edge of shadow where day becomes night. The transition is so clean it looks drawn by hand. Above, the Milky Way arches in full glory, a river of light winding through darkness. You follow its path across the sky, tracing the gentle curve of its arms. You know that somewhere within that band lies Sagittarius A, the black hole you visited, and beyond that the clusters, filaments, denouements, and voids you've drifted through. The scale should overwhelm you, but it doesn't anymore. You've learned to think in light years the way poets think in metaphors, less as numbers, more as relationships. A quirky historical thought surfaces. When the Voyager probe left the solar system, scientists programmed it to keep measuring the density of particles, even in near-empty space. They expected the readings to drop to zero beyond the heliosphere, but they didn't. Even interstellar space has texture. A faint background hum of atoms and magnetic fields. The cosmos, it turns out, never becomes nothing. Everywhere, something persists. You like that. It's proof that even emptiness isn't truly empty. It's full of potential, waiting to be noticed. You tilt your perspective outward once more, zooming mentally until the Milky Way becomes a single swirl among countless others. Then farther still, until galaxies blur into threads and knots, the great cosmic web spanning everything. You recall how dark matter stitched it together, how dark energy keeps it expanding, and how, from that view, no single galaxy dominates. They're all equal in their insignificance and in their brilliance. The universe looks less like a hierarchy and more like a collaboration. Historians still argue whether the term cosmic web does justice to what it describes. Some physicists prefer cosmic fabric, others universal foam. But names are human conveniences. The universe doesn't label its own architecture. You realize that language, while miraculous, always falls short. Words can't hold infinity, they can only point toward it. And yet that pointing, that attempt, is what makes language sacred. It's humanity's way of saying we noticed. You drift downward again, letting the stars fade behind the sunrise. The light grows thicker, warmer, alive with colour. Somewhere beneath the clouds, someone might be stepping outside to watch the morning sky, not realising that the photons touching their face began in the core of a star, travelled 93 million miles, and arrived precisely now. You find that precision comforting, the way the laws of physics choreograph beauty without trying. It's the most elegant kind of accident. A quirky modern anecdote glows in memory. When astronauts aboard the International Space Station photograph Earth, they often comment that the hardest thing is choosing where to point the camera. Every angle is perfect, every horizon impossibly graceful, one said. The planet poses for no one, it just is. You grin, thinking that the same could be said of the universe. It never performs, it simply exists, magnificent and unaware. You close your mental eyes and replay the journey. The nebulae where stars were born, the black holes where light folded, the clusters like cities of suns, all of them flicker through your mind. Each region you passed had its own rhythm, its own lesson. Nebulae taught patience, black holes taught humility, the cosmic web taught connection. And Earth, with its tiny orbit and noisy inhabitants, teaches gratitude. The scale of the universe doesn't diminish that gratitude, it amplifies it. Historians still debate the ultimate fate of all this. Some say the universe will expand forever until even atoms drift apart. Others suggest cycles of rebirth, each big bang following another like breaths. You decide it doesn't matter. Whether existence ends or loops, it has already proven its genius by producing awareness. The ability to marvel, to understand. Maybe that's the universe's hidden purpose, not just to exist, but to notice itself through you. You open your eyes again, if only in metaphor, and take one final look at the Milky Way. From this perspective, it's a glowing curve stitched through the night, fragile and eternal all at once. You realize that your galaxy, though small compared to the universe, is more than enough. It's a complete cosmos within the cosmos, a self-contained story full of light and motion and time. Beyond it, more stories unfold, but you don't need to read them all to feel whole. A final quirky detail comes to mind. Astronomers estimate that new galaxies are still forming into the farthest reaches, even as others fade. Creation hasn't stopped. It's ongoing, continuous, open-ended. The universe writes in present tense. You laugh softly. It's comforting to know that while you end this journey, the cosmos never does. Somewhere right now, another star is being born, another question being asked, another answer forming from light. You breathe, figuratively, though it feels real, and let the enormity settle into quiet acceptance. The Milky Way is just one galaxy among billions more, but it is yours. The universe is unfathomably vast, but it fits neatly inside your imagination. Scale, you realize, is irrelevant. What matters is awareness, and you have carried that across the stars. You've seen the beginning, glimpsed the edge, and returned home wiser. The universe hasn't changed, but you have, and that's enough. The stars around you softened until they seem to breathe. Their sharpness blurs into something warm and hazy, like embers fading in a fireplace after everyone else has gone to bed. You hover in that dim hush, feeling the vastness of everything loosen its grip, the numbers and distances slipping quietly out of focus. The universe no longer rushes or roars, it sighs. Even the Milky Way, that bright ribbon of memory stretching across the dark, feels less like a map and more like a lullaby drawn in light. You turn your thoughts inward, back toward the slow rhythm of a single planet circling a single star. From here, Earth is only a pale shimmer, but you can almost hear it. Waves rolling against coasts, leaves turning under wind, the faint percussion of human life. After all those billions of light years, the sound is impossibly intimate. You realize that meaning isn't scattered out there among the galaxies. It's condensed here, in the fragile warmth of home. The cosmic scale doesn't diminish it. It protects it, the way silence protects a whisper. Every breath becomes slower now, each one stretching a little longer, as though your lungs have learned something from the expanding universe. The body relaxes, the mind drifts, no longer needing to chase comprehension. Facts and theories dissolve into sensation. They're weightless, endless, kinder. You think of the galaxies still spinning far away, of the light that will travel for billions of years before meeting another curious eye. Somewhere someone will look up and see what you've seen, and this wonder will begin again. That thought is enough to make the darkness feel friendly. The stars dim one by one, folding themselves gently into the night. Even the hum of the cosmic background fades until only quiet remains. You let it fill you, this final silence that isn't empty at all but full of calm, like the pause between heartbeats. Time stretches, bends, and finally smooths out completely. You're no longer falling through the universe. You're floating within it, perfectly still. The distance between galaxies, between seconds, between thoughts shrinks to nothing. And there, in that nothing, peace expands.